A very warm hello and welcome back to all our viewers. Thank you for joining us on day 2 of the Global Additive Manufacturing Summit 2021. For those who missed out on day 1, let's have a quick recap. Yesterday, we had 10 amazing thought leaders who shared their AM investment journey on a global scale from both the startup and VC perspective. We also explored the capabilities of AM in digitalizing the global supply chain and its benefits, such as on-demand printing and spare parts production. Today, our focus will be on future casting, on how AM will break new grounds with emerging applications And what social impact will the use of AM bring? Similar to yesterday, our main conference will take place across 2 sessions today, and we will begin with exploring the emerging applications of AM across various sectors, including biomedical, food, recycling, and metal production. So, before we officially begin with our session on emerging applications, I would like to warmly welcome our session chair, Mr. Aditya Chandavarkar, who is dialing in from Mumbai, India. Aditya is the co-founder of Indian 3D Printing Network, which is a knowledge sharing and business networking platform for the AM industry in the APAC, Middle East, and Africa regions. On top of that, Aditya has kickstarted a training and education initiative on Indian 3D Printing Network, coined Additive Academy, to provide comprehensive additive manufacturing and 3D printing training. His knowledge and passion for AM is definitely clear to us. So today he is here with us, Aditya, to helm the emerging applications session. Aditya, I'm so excited. So yeah, I can't wait to have you on board. How are you feeling today, and how are things in Mumbai?
Yeah, great to be back, Mahendran. And I was the chair last year for the Global AM Summit, and good to see it coming full circle this time. And definitely glad to be helming this session on emerging applications. So that's a great thing. And Mumbai is great. Good to see business coming back after a long break in the pandemic. Things getting back to normal. So that's a good sign for everyone. So going well. So before we start today's session, let me invite all attendees to leave your questions in the Q&A panel on the right side of your screen, and you can leave them at any point in time as we hear from our speakers. These questions will be answered live in the panel discussion right after this. So, all right, let's dive into our lineup for today. Starting off the session, we have Mike Graffeo, the co-founder and CEO of Fluidform. Fluidform is transforming medicine by creating human tissue for drug discovery, surgical repair, and organ transplants. And through his career, Mike has worked on the forefront of medical technologies, translating high complex products and clinical data into successful business. Today, we will hear from Mike on commercializing tissue engineering, a fresh approach. Next up, we'll have Benny Buller, who will be presenting the changing risk-reward profile of metal AM. Benny, as we know, is the founder at Velo 3D, and Velo 3D provides an integrated suite of hardware and software to provide end-to-end metal additive manufacturing solutions. And these solutions seek to overcome the flaw of engineers needing to learn a new manufacturing process and a new design process in order to adopt AM. After Benny, we will hear from Mr. Arthur Huang, the co-founder and CEO of MINIWIZ. And MINIWIZ technology, interestingly, captures the value of single-use plastic, metal, glass through decentralized waste transformation machines to convert industrial and household wastes into sustainable building materials, building modules, specialty fabrics, designer furniture fixtures. We can see MINIWIZ projects implemented across various cities, and Arthur will share them with us in the presentation on Upcycling Beyond Imagination, a smart technology solution for plastic pollution. Last but not least, we have Daniel Dikovsky, Head of Innovation and Technology at Redefine Meat. Utilizing over a decade-long experience in 3D printing, his position sees him lead a team of scientists to change the way we make our meat through an entirely new and innovative technological approach using additive manufacturing technology. With that, Daniel would be bringing us addressing the complexity of whole-cut meat with a complete new technological ecosystem. So Mike, if you're ready, the stage is all yours.
Good morning. I'm Mike Graffeo, CEO and co-founder at Fluidform, the regenerative medicine company. I'm excited to speak to you about the latest advances in the field of regenerative medicine. As you're probably aware, the field of biology is extraordinarily complex. Whether it's shapes and sizes, whether it's structure or function, things like anisotropy of materials, vascularity, microporosity, and all of the complex interdependencies to create functional parts of the human body have been a challenge that has been hard at work for the last 25 years trying to solve in the field of tissue engineering. We've made great advances, and there's a lot more work to do. In the field of tissue engineering, there's really been two fundamental approaches to date. Approach number one, I might describe as letting the biology do the work. This has been leveraging animals and cells to do the work of complex assembly of proteins and cells, extracellular matrix, and growth factors in order to create things that have some function that resembles what happens in the body. For the last 25 years, these approaches have been trying to advance in order to get to places where we have real functional tissue, and they've made great strides. The challenge in the area of letting biology do the work is that ultimately it's very time consuming, it's very costly, and our ability to exert engineering levels of control are really limited. As a result, there have been a number of efforts on what I'll call biomanufacturing approaches. These are anything from conventional manufacturing technologies like casting and molding to more novel technologies like additive manufacturing, using technologies developed in manufacturing to attempt to work with the materials inside the body. This holds a great deal of promise, and there's also a great deal of challenge in order to do it well. The reason why it's so complicated is because the biological materials are ultimately soft, deformable, and therefore difficult to assemble. For almost anybody in this audience, if I were to give you the mechanical watch in the top of the screen and the right set of instructions, you could put that together with enough time. But if I were to give you the watch in the Salvador Dali painting below, it would be nearly impossible because nothing stays where you put it, and there's no way I could give you the right set of instructions to do it. Biological materials are quite similar in that the biological materials are soft, deformable, they don't stay where you put them. So bringing them to bear in a field like additive manufacturing is quite challenging. In fact, what you see on the screen here is collagen, native collagen, unmodified, which is the biggest component of the extracellular matrix, being printed out of a 3D printer. And what you might notice is that rather than making shape and structure, it's making a puddle. That's because collagen does not self-assemble on its own without some kind of control over the chemistry. So what do we need in order to actually get there? Well, we need to be able to work with the right materials. We know a great deal about how biology works with the cues of its environment. So we need to be able to control that environment. That includes working with the right materials. We need the right kinds of structure, the right shapes and sizes and material composition to drive mechanical as well as those biological signals. And ultimately, we need the right types of assembly in order to let biology do what biology does best. So at Fluidform, we've licensed a technology that's been developed over the last decade out of Carnegie Mellon called FRESH. FRESH, which stands for Freeform Reversible Embedding of Suspended Hydrogels, allows us to deposit native biomaterials into a support material and keep them in place and control the chemical environment around them, which lets us use a lot of different chemistry to be able to control the gelation and the solidification of these materials. This enables us to work with the widest range possible of native biomaterials, from collagens and proteins, growth factors, and cells. And the way we're able to do that is very similar to, for example, the way you're able to squeeze toothpaste out of a toothpaste tube. It's like a solid standing on top of your bristles, but it flows like a liquid when you apply enough force. The support materials that we work with do the same thing, and that's at the core of the IP development that happened at Carnegie Mellon that resulted in the creation of Fluidform. Now, over that decade at Carnegie Mellon, there were a number of key publications. In fact, FRESH is by far the most published and most cited biofabrication platform in the world. The highlight publication in 2019 was on 3D bioprinting collagen to rebuild components of the human heart. And I'd like to share with you some of the capabilities that were published there that at Fluidform we're able to take really to the next level. Among those capabilities are the control of porosity, control of anisotropy, and control of the ability to create vasculature. As you can imagine, porosity is really important to control because when we're working with cells, the ability to let cells do what they do natively in the biology is mission critical. So creating monolithic materials like we might do in casting can create real challenges to cell infiltration and migration. With Fresh, we're able to control that microporosity, which allows cells to infiltrate and migrate into scaffolds, for example, much, much more effectively than any other technique. You can see here that the penetration, the infiltration of cells into a fresh printed scaffold goes much, much deeper, almost an order of magnitude deeper than what happens in a casted structure. And on this video, you can see the zoom in and the real fidelity and control that we're able to get with that microporosity, because we can control the size and shape of the materials inside the support material. On this next slide, you'll see our ability to create vasculature. And this is an important hallmark. Most technologies, most techniques don't have the ability to control the voids they leave behind, which means it's impossible to pattern vasculature without some kind of sacrificial material or otherwise that's embedded in. With Fresh, we're able to leave space because of the support material that we print into, and that allows us to create all sorts of complex branching vasculature and vascular networks. What you see here on the slide is a computationally generated vasculature based on data taken from real patient MRI. That computationally generated vasculature is then printed, and what you can see in the bottom right is actual perfusion of that. So you can see the ability of the blood flow to branch into multi-scale branching architecture. But that large-scale vasculature isn't the only important part. The ability to get all the way down to complex microvasculature is mission critical. What you can see here is the difference between casting a construct and fresh printing a construct that are otherwise identical. By controlling that microporosity, we're able to leverage the benefits of VEGF, for example, to drive a significant amount of microvascularization on implant. And in fact, on this video, you can see that this was hooked up to the host inside of an animal model and goes all the way down to the capillary scale. Now, the ability to pattern, anisotropy and porosity and vascularization all sound fairly abstract. Why are they important? They're important because it's only helpful if we're biofabricating things that actually function. So we'll walk through a couple of examples of functional biofabrication that's happening here using our technology. On this first slide, you can see my co-founder's work in recreating the function of a heart valve, right? So starting with, data taken from patients, in this case from the NIH, recreating that exact same shape, size, and processing that material in order to make that robust enough to stand up under real pulsatile flow. This is an example where actual patient pressures are applied to a valve. You can see the hallmark opening and closing of that valve in order to preserve the right kinds of function. This is one of the really first examples of biofabrication using 3D printing and other technologies to recreate, complex, real physiologic function. And next, we also demonstrate some of the complex cellular function that we're able to create. By controlling for that anisotropy, the way that we lay down materials, the shape and direction that we pattern them in, we can control the alignment of the muscle fibers. Here you can see on the bottom in green, the alignment of cardiomyocytes that are printed into a cardiac ventricle model. By aligning those cardiomyocytes, we can control the way that they beat and the way that electrical action potentials propagate along them. So we're able to print a complex, very, very highly dense cellularized left ventricle model, and then to see it functions. First, you can see in the middle of the screen here on video, the beating of that, and you can watch that calcium imaging demonstrate the action potential propagating circumferentially around the ventricle. And here we can also see from the top down that circumferential propagation that happens with spontaneous beating, and on the bottom, the point stimulation of that. When we measure the action potential propagation by point stimulation, we can see that it's much, much faster circumferentially around the ventricle than it is in any other direction. That's mission critical in order to start to recreate not only proper function, but to explore improper function, things like complex arrhythmias. If we can have that type of conduction velocity differential, we can start to understand the effects that happen when, for example, different arrhythmogenic drugs interact with real physiologic tissue. And last but not least, it's mission critical that any technology that works to biofabricate not only works at the size of a postage stamp, but works all the way up to the size of a real organ. At Carnegie Mellon, they were able to demonstrate in 2020 the ability to print all the way up to a full-size heart, in this case here, out of an alginate material to demonstrate the size and scalability. scalability is one of the most important factors to consider when we think about how to grow the field of biofabrication into real functional useful applications. We've got to have applications that drive speed. We've got to drive reproducibility and reliability. And at its core, we've got to be able to validate those things. Having put 4 different products through FDA and other regulatory bodies around the world, I'm well aware of the challenges associated with being able to demonstrate the repeatability and reproducibility of making what you intended to make. At Fluidform, we've been tackling these challenges for multiple years and believe we have the most advanced biofabrication platform in the world at our pilot facility here outside of Boston. At that pilot facility, what we've been working on is actually advancing real commercial applications of this technology. Those include areas like tissue for training and 510K medical devices, where we're working with some of the best partners in the world, as well as advanced pharmaceutical assays, leveraging that complex ventricle and its architecture to understand the intricacies of how different kinds of drugs affect both cardiotoxicity, as well as leveraging that as a disease model to understand what different types of drugs might be able to treat conditions like arrhythmia. In the long arc, we expect to be developing, and we have an active program today looking at a next generation heart valve that will bring transcatheter heart valves to many, many more patients who today are ineligible for it. And yes, over the long arc, we also expect to be building cellular tissue for implant. This is the holy grail. This is the area that everybody's wanted to get to for a decade. And it's a really, really interesting, complex challenge that is very difficult for anybody to credibly say today, we're going to jump from research into cellular tissue for implant. There's so many challenges along the way that at Fluidform, we believe that by building this ladder, this staircase to get there, we've de-risked a number of these programs to help us increase the likelihood of success. So I hope I've been able to convey to you the challenges associated with the field of biofabrication and why at Fluidform, our fresh approach to how we do things represents a real differentiated solution. Thank you very much.
Hello everyone, my name is Benny Buller and I'm the founder and CEO of Velo 3D. I'm extremely excited to be with you. I would have been even more excited to actually be with you physically, but this is the national holiday of Thanksgiving in the United States, so I couldn't make it. So if you think about metal additive manufacturing, it has a fantastic applications in aviation, space, energy, defense, as well as in many other industrial areas. The promise of additive manufacturing is driven by higher performance, much better products, as well as dramatically shorter lead times than what you can do today. The market opportunity for that is massive as well. We are talking today of additive manufacturing parts taking about 2% of the high value metal parts market, and we believe that by the end of the decade we could drive this adoption to 20% of the market. So this is a real great opportunity. So the challenge has been the risk-reward profile, and that's what we are going to discuss today and how it's going to be improved. At the heart of the problem is the underwhelming capability of the existing additive manufacturing, which means too little reward. The additive manufacturing today is far from limitless. It requires new design rules that are called in the jargon Design for Additive Manufacturing, or DFAM. The supports and the existing orientations are not enough to open the market, and we are really trapped in a world of what is accessible from the outside. The solutions we have today are failing to overcome the limitations, and if you look at that, the parts that would be the most ideal candidates for additive manufacturing would have to be filled with so many internal supports, rendering the production of those parts with additive manufacturing not practical. In addition to that, everyone makes their parts in a different way. There is no scalable supply chain. This means too much risk. There is a huge variability between system to system, and there is a variability between different manufacturers using the same systems. The qualification of manufacturing is expensive and is repetitive and requires people to do it again and again. This all means too much work, too much risk, not enough reward. So how do we change that? Our breakthrough that Velo 3D has put together is enabled by an end-to-end solution. This is a solution that includes Flow, the print preparation software, Sapphire, the printer that is actually producing the parts, Assure, the quality control software. Underlying all that is our unique and proprietary manufacturing process, the intelligent fusion process that is prescribed by Flow, implemented by Sapphire, and validated by Assure. Our support-free process that is enabled by our intelligence solutions enables customers to make the parts they really need in the simplest way possible, so that they are coming from the printer with all the critical internal surfaces at the right shape and form already. You can see that through the impact that we have made on some of the customers we have been working with. SpaceX has been attempting one of the greatest challenges in human history, the colonization of Mars. We are enabling SpaceX. The most challenging part of the rocket is the engine, and the Raptor engines are designed and produced around the capabilities of our manufacturing technology. We open new categories of metal additive manufacturing parts. These could be static or rotational parts optimized for the control of flow, of fluids, as well as the transfer of heat. As our product portfolio expand, the envelope of the parts that could be manufactured on our systems expand as well. The original Sapphire system had a radius or diameter of 315 millimeter and build height of 400 millimeter. The Sapphire MZ has been expanded to 315 millimeter in diameter by 1000 millimeter height, and the new Sapphire XC has a 600 millimeter diameter and 550 millimeter height. All those systems utilize the same one unitary manufacturing process and the same flow and assure software. The materials that are available are a number of nickel alloys, as well as titanium, aluminum, and high-strength aluminum. We are also bringing to market copper, as well as stainless steel and additional nickel alloys. With that, we are decreasing the risk variability and risk, in addition to enable geometries that were not possible before. This relies on the concept of copy-exact additive manufacturing. All our machines are matched and they are calibrated internally every run to achieve the same process outcomes. The processes are matched and are driven by universal library of standard processes. This means not every customer do not have the ability to tailor the processes or to change the processes. All the customers, all the contract manufacturers, they are using exactly the same recipes, accomplish exactly the same outcomes, regardless of where the machine is in the world. This is accomplished by our intelligent software analyzing the parts and applying the right parameter sets. The parameter sets are applied from a standard library that is optimized to provide the optimal outcome for every section of the part, depending on its geometrical context. The result is a single file that is created that is independent of user or calibration. Directly from the cal file, it generates the print preparation using our print preparation software, the file that then is going to the machine. The machine is then automatically calibrated to produce with the same file the same outcomes every time the part is run on any machine that is executing this print. On top of all that, the machines are connected to our Assure quality control software that is then producing a comprehensive build report that is validating the quality of the print and the parts that are successful versus risky or failed in production. The result of all that is a distributed supply chain that is enabled as a copy-exact supply chain. So think of each one of the machines as a copy-exact factory that is producing the same parts using the same recipe from the same digital file anywhere in the world. Completely scalable, the first scalable additive manufacturing solution. Through all of that, we are changing the equation to open the market. We are increasing the reward, addressing the most impactful business cases and opportunities, maximizing the performance gains, reducing the time to market, and while doing this, we are decreasing the risk, creating a redundant supply chain, validating the part quality and standard material properties. Thank you so much. It was a pleasure talking with you today.
Hello, my name is Arthur Huang. I represent this company called MINIWIZ. We've been focusing on trying to turn trash into new materials for the last 17 years. We will try to employ as many smart technology, as much new generation of manufacturing as possible to turn plastic pollution into the building solution of the future. So a quick introduction of who we are. The mission has always been zero waste and beyond. It was trying to make ourselves, our daily life, and trying to turn post-consumer waste into new generation of resources for the future. Basically, be more like nature. Who we are, we identify ourselves as a trash material innovation company specialized in circular construction. So we are mainly a bunch of engineers who came together with this office. We develop machines, materials, and manufacturing processes. And the vision is to turn, we've been doing so much construction, ESG construction globally for the last 15 years. We have built over 300,000 square meters of commercial spaces worldwide. And right now we are scaling globally with real estate partners. And that's how we can gain the very valuable scale partnership that all sustainable solution needs. Okay. So this is a quick video of who we are. This is 2 minutes.
We want to matter.
Please bear with me.
We want to matter to the non-toxic future of our world. We want to matter to the sustainability of our community. At MINIWIZ, it is our mission to change consumer behavior into a circular one. It is the only way for us as a species to sustainably consume our limited resources. Overconsumption is a complex system problem. There is no single miracle cure. We want to matter by proving human consumption can be satiated with our very own trash. We have dedicated ourselves to turning decades of environmental pollution into solutions that will enable us to live sustainably. We want to matter, so we turn ourselves into magicians of trash, inventing new ways of transforming our everyday trash into high-performance works of art. We turn milk packaging into the hottest sportswear fashion, plastic bottles into luxurious textile, cigarette butts into furniture and glasses, using fashion and apparel waste into luxurious home furnishings, mask, PPE into cell phone chargers, single-use medical waste material into hospitals, using smart AI technology to make decentralized recycling, upcycling possible today.
We head to Taiwan for this report, a company designing solutions to overcome a mounting problem of a mountain of trash. From furniture to hospital wards, all built from waste, one CEO is on a mission to revolutionize recycling.
His team has used waste to develop over 1,200 different materials for use in construction, a company turning different kinds of waste, like plastic bottles, into materials for buildings and products across the world.
We want to matter, but unfortunately we are out of time. Please join us in upcycling today's local pollution into circular ESG building solutions of the future.
Okay, so basically turning all that waste into building material, and you guys, I think this is a very important point, is to have a scale match. There's a lot of waste, but building material also consume lots of materials. And later you might ask, how is that related to 3D printing? I think 3D printing has integrated into every single piece of our process. Later you can very see clearly from the facade you see here, all the way to the facade you see here. All the prototyping are done in 3D printing. And recently we are doing 3D printing already in metal to create a tooling directly to use in our smart machineries. All this is to what? To generate placemaking projects. What does placemaking means? Means actually you want to collect the material from the inhabitants that you serve. Why ESG? Like, so all the materials made locally, collected locally, to create these public projects where people feel and identify as part of their own building. So, and how do you do that? You need to have decentralized manufacturing, and decentralized manufacturing require very adaptive system, and that's why I say 3D printing is integrated into every single one of our process. From every single one of these tiny bricks, all the way from the prototyping, all the way to the toolings, we definitely use a lot of 3D printing, like prototype, and all the way to the manufacturing in every stage. Now, who do we serve? This is who we serve. We serve a lot of major clients. We build spaces for them, ESG related spaces for them, from Nike's headquarters in New York, Philip Morris's, these what we call gallery spaces across Italy, Nike lab stores across the world, from New York, Tokyo, Paris, London, Milan, Hong Kong, Shanghai, etc., etc. They are all made from waste. So these are made from shoes. Those are made from recycled plastic bottles with oyster shells to create antibacterial quality, all the way to cigarette butts. This is just an overview of how much stuff we have completed. But the main thing is that we need to create new materials. And by creating new materials, you need to be able to prototype very, very quickly. So the data, because many of our engineering software require material data. And so we need to always test it, whatever we propose, in a scientific way. So we can get through all kinds of certification on different countries. So, and this is how we integrate many of our capabilities into a real estate lifecycle supply chain. For example, from the engineering design services that we're integrating all the way from the feasibility service all the way to the design process. And the B is like we already pre-develop a series of adaptable building products, which can be manufactured using local waste and local machineries. Again, when it comes to local machineries, 3D printing becomes super important for us. So we have worked with 3D printed cement columns. We have worked with 3D printed molds to press these insulation panels. And all the way to what we call decentralized manufacturing platform. Basically, it's a series of smaller machines that can be shipped across the world and can integrate into every one of a process in different locations. In 2020 and 2021 is one of the worst time of the world, most transformative. We did a couple of meaningful projects we did, which in Singapore, for example, one is a PPE recycling plant. It's basically turning PPE gowns and bed sheets and pillows and blanket in all the isolation sites. And we are turning that into PPE fabric. So it can be used as PPE fabric again, and also can later turn into architecture material when there's no pandemic. And another one of a project highlight for this during this pandemic time is the medical grade hospital wards, also designed for pandemic. In Taiwan, we built 96 of these ICU hospital wards, all made from local recycled material. As you can imagine, during this time, shipping globally is actually disrupted. So in order for us to collect materials, not be able to import material, medical grade building material from Japan, from United States, we have to actually build it ourselves. So we actually use these machineries and local resources to be able to prototype and manufacture this hospital ward very quickly and actually pass all the certification. By the way, all the joints here are 3D printed. This is the first prototype. So the whole prototyping, this whole thing, except the panel and these insulation panels and the hospital bed, they are all 3D printed joints in this whole thing. And this is the actual final product of the final result. So some of the material are still 3D printed. The mold to make these hinges for the doors on the hinge, and all the capping, all these for these smart AI cameras to link to reduce the use of medical staff to take care of the COVID patients. All these capping of these digital sensors, even the panel system, because everything is custom. So during this COVID time, everything we did is we 3D print everything, okay? And we print, you can imagine, 96 of them. That's not that much, but for the price for a medical standard product, it's quite easy to meet all the different design specifications. And this is just a quick idea, so people know how we design as in a modular ward, and how it can adapt to different functions. And why this new dry construction revolutionized the way how hospital is being built, especially ICUs and these very complicated units. All the panels are all click in place. There's no glue. And you can see those joints are all 3D printed and then later extruded in massive quantity. And so the only material used are locally recycled aluminum and recycled polypropylene and recycled PET. So this is a hospital made from trash. And a lot of people might ask, like, where is this going? Yes, it's not just going in the hospital, it's also going to the new generation of smart schools. This is National Taiwan University, and is using this system to build this new generation of collaborative smart classroom. And we are also doing that for hotels now, because many hotels got converted into hospitals. So we are also integrating this system into hospitals. And lastly, I just want to present this mobile intelligent recycling system. How's that related to 3D printing? Please notice that many of these 3D molds are actually 3D printed, not CNC, so we can quickly customize as many as possible. So here's the last video, and then
4 years ago, MINIWIZ started a journey to create the first mobile recycling line, the Trash Presso. Using press machines, shredders, ovens, and other industrial equipment, Trash Presso is able to recycle trash anywhere. While TP1 traveled around the world, MINIWIZ developed a new generation of Trash Presso. A modular system with a smaller footprint for easier transportation and higher energy efficiency. With a new system of heat induction presses and specific molds for different parts, the process has become faster and more efficient. The new Trash Presso complements Robin, MINIWIZ's smart trash collection system. We will track every single piece of your trash from the moment you throw it away till the time we put it back in the game. Furthermore, new Trash Presso can be upgraded with a robot arm that will do the dirty job.
Okay, so this has traveled around the world, and I think hopefully you will see more of this coming online. And we started this whole revolution, I started in Singapore at the Tapayo with the Ministry of Environment and Water Resources, sponsored by Nat Geo. So this was the very, very first version where we started the whole experiment to try to use the localized, decentralized machineries to be able to upcycle trash as quickly as possible within a 3-minute cycle. Okay. And you can produce lots of different products from mosaic tiles all the way to consumer goods, all within 3 minutes. And this is the latest one that we are producing using mask recycle, and these are auto eject molds. and these are actually made already from literally the mass directly put into the machine, and with a robotic arm, it can actually be made completely automatically. And thank you so much. Hopefully you get to see that in Sweden, Beijing, and Qatar, and Monaco soon, later. Thank you.
Hello, my name is Daniel Dikovsky, and I lead the technology and innovation at Redefine Meat. Our company is developing and producing the new generation of animal-free meat. We use plant-based ingredients together with advanced manufacturing technologies, including additive manufacturing, to make the perfect steak without the animal. I'm coming from a background of chemistry, and I had my PhD in tissue engineering, where I grew 3D-dimensional bovine tissue cultures for medical applications. So I'm familiar also with the science behind cultured meat that is so popular these days. Then I worked for Stratasys and Objet, developing multi-material 3D printing technologies for various applications, including biomedical applications and the printing of synthetic mimics of human organs. Maybe you're familiar with this product under the name Digital Anatomy Printer. I had the chance to become familiar also with the 3D printing research in Singapore during one of my visits, aimed to disseminate the 4D printing technology that I developed together with Skylar Tibbets from the MIT. I switched to Redefine Meat 2 years ago in my endeavor for new technological fields that can benefit from additive manufacturing. And in this session, I will tell you about Redefine Meat vision, technology, and the role of additive manufacturing in our process. I will begin with telling you why are we so obsessed with making the new animal-free meat. Well, I guess that you may agree that we live in strange times and face great challenges, probably greatest ever. The life on our planet is not sustainable anymore given our population and our way of living. And it is us who created this problem in the first place, and we are the ones to address it. It's a great responsibility and great opportunity to make a change. So how do we deal with this? Obviously, the way to address the environmental issues should involve all aspects of our life, our behaviors, perceptions, priorities, and efforts. Some of those aspects lie in the educational and cultural doctrines, but others are essentially technological. The education alone cannot provide an efficient solution. You cannot make all people reduce, reuse, and recycle, travel by bicycle, buy organic food, and avoid meat. It just doesn't work, at least not in the short term. So we need technology to drive the changes that we want to see in the world. Technology to make clean energy, efficient machines, communication without boundaries, and of course, a sustainable nutrition. And today we understand that sustainable nutrition is critical for making the difference. The food industry has a huge impact on the environment, and the meat industry is leading the list with the enormous contribution to waste, pollution, and greenhouse gas emissions. But we love meat, and it's totally rooted in our life and culture, and probably even on a biological level. And at the same time, we realize how outdated and inefficient and cruel is today's animal farming. So how can we resolve this conflict? I will state that it's about addressing 3 criteria: efficiency, nutrition, and hedonistic pleasure. And we must address all 3 elements to shift the preference from animal meat to animal-free analogs. Today, it is clear that the animal-free analogs are able to provide us with the complete nutritional profile, and it is clear that it is much more efficient to go directly from plant to protein rather than doing so through an animal mediator, right? Yet, the hedonistic factor is still lags behind. And why is that? It's because the meat is just so difficult to mimic precisely. So this shows you the anatomical structure of a meat fiber and of the muscle tissue. It was made through thousands of years for a certain function. Think about it. The animal used the muscle for movement, right? And think about how long it took us to get a fair mimic of much simple product, like milk and cheese, and even they are not perfect yet. So how can you do this with meat that is so much more sophisticated in its structure and sensorial characteristics, and it is used in so many dishes in diverse cooking methods? The meat is actually a set of structural, physical, and chemical parameters that together form the texture, appearance, and flavor that we are so familiar with. And all these vary between the different breeds of cows, right? Cuts, the different locations in the cut, and also differ between as a result of different thermal history, the cooking method. And it's not surprising, though, that we have such a challenge in providing this through plant-based analogs. And although there's been a major progress since companies like Beyond and Impossible revolutionized the market, their technology is still limited to mincemeat and chicken products. The whole muscle beef, and specifically the premium cuts, are the holy grail of the market. But now, having the complexity of this task in mind, you should ask whether it's possible at all to make a perfect animal-free steak, and how can we do so? My answer is definitely yes, and that it's only a matter of technological investment. If the humanity was able to make a Pentium chip that you see on the left that has more than 20 billion transistors planted into the highest purity material on Earth, which is the silicon, and sell it for $15, then we definitely should be able to fabricate a perfect steak. A 200-gram steak has the same amount of living cells inside as the Pentium processor. And it's not only something that we see in the microelectronics industry, we see this also in the 3D printing industry. So here you see on the left two pieces designed by Neri Oxman and printed in our collaboration during my work in Object. And each one of these pieces contains more than 20 billion droplets of the resin. So these levels of complexity are already achievable in our technology, and that's one of the reasons that our company also is using additive manufacturing to achieve this level of complexity for meat. It's not our only technology, but it's one of the elements that are delivering this level of complexity. Our motivation to use additive manufacturing is similar to other industries. We need the capability to quickly redesign, to produce on demand, mass customized products, but most of all, we need the structural complexity that cannot be achieved by traditional food manufacturing technologies. So while in plastics, the additive manufacturing is used mainly for the complexity of form, here we are mainly interested in the complexity of the internal structure. Remember the muscle anatomy and the fibers? With the help of additive manufacturing, we can address this complexity. And in the end of the day, our meat making process is about recreating each element of the meat separately and then putting the elements together by additive manufacturing. But our technology is more than just the process. It's about studying the meat. It's about understanding the structure to the very depth, becoming #1 experts in meat, and building a comprehensive model of meat and understanding its composite structure and function. It allows us then to break the meat into components and reverse engineer each component separately and make a system that's capable of putting these elements together according to a digital file. This allows us optimizing the whole process and building a modular system, a kind of a factory in a box that can be easily translated to anywhere in the world. So the first element of our technology, as I mentioned, is understanding the meat. So we use existing expertise and carry on also our own studies for mapping the mechanical, sensory, and culinary properties of meat. We work with Professor Peter Perslow, one of the leading meat scientists in the world, to deepen our knowledge in subjects such as connective tissue, meat color, and changes that occur during cooking. But besides that, we also develop our own methods to measure and quantify the different aspects of meat's experience. One example is a study that we ran together with Canadian light source facility aimed to 3D map the structure of the muscle fibers in raw and in cooked meat using focused synchrotron beam. On the right, you can see a section from a CT scan of a tenderloin sample. It's muscle fibers and connective tissue. While it's not difficult to get this in 2D by microscopy, here it's actually a three-dimensional structure, and it allows us to reconstruct the 3D arrangement of fibers in real meat pieces. Then second, as I mentioned, we break the meat into components and reverse engineer each component by animal-free formulations. We make the best muscle, fat, and connective tissue. We make the right colors, flavors, and juice, and each formulation has a dedicated deposition mechanism. Here you see an early version of the system. Today, the modules look and behave differently, but the concept stays the same. Third, we develop fabrication systems capable of manipulating all the components to form the right structure and resemble the digital meat model based on the data collected in the first step. Here you see some digital models and the way they are converted into a marbled meat structure. Number 4, we quantify the resulting meat. We characterize the structure and transform it into numbers through a set of analytical methods. Some of them are common, such as the TPA method, and some are custom, developed in-house to address some specific characteristics of interest. For example, shear test, tensile testing, image analysis, and different rheological measurements. In the end, this whole meat fabrication process fits in a single box, kind of food factory in a box, and it provides a complete solution for new meat production. It allows you to feed in the raw materials, fabricate the meat slabs, control the process, and of course, maintain a complete food-safe environment. And having the whole process in the box allows us to rapidly scale up and disrupt the logistic chain for our meat. This is done by establishing local material manufacturing sites, and then the actual meat production by installing our fabrication systems as close as possible to the end customer. In the end of the day, this approach allows us to advance very quickly towards our goal, which is replacing the cows, saving our planet's resources, recovering the lands that are used for animal farming and animal feed, and reducing the pollution without compromising the meat eating experience. So where do we stand now? Well, we have a great whole muscle beef meat in our labs, and we taste it on a daily basis, collecting tons of sensory data and getting slightly better with every redesign cycle. It will see the market later this year in Israel and then reach Europe early next year. Meanwhile, we've accomplished the conversion from a small technological startup to a full-scale meat company and already manufacture and sell a range of minced products here in Israel since July this year. We receive awesome feedbacks from the customers and from our culinary partners and feel we're on the right way to making our meat a whole different animal. However, there are plenty of challenges along the way, and we are working on identifying and removing the major barriers for making the animal-free meat a reality. And we believe that we cannot do this alone, and we invest major effort in creating an ecosystem that promotes synergy between all the players in our industry. We must join forces for accomplishing the new meat revolution together. That's all. Thank you for being with me.
Thank you, Mike, Benny, Arthur, and Daniel. That was really exciting to hear all the upcoming applications of additive manufacturing across all these different sectors. And I hope this inspires all our budding innovators out there, and perhaps we'll see your innovations next year in our sessions on emerging applications. All right, Aditya, I know you're all ready to engage with our panelists after their wonderful presentations, and I shall not hold you back any longer. Let's kick off the live panel discussion with our session chair, Aditya, and our distinguished panelists.
Yeah, Mahendran, it's really great to see the emerging technologies across various applications. We heard about tissue engineering, recycling with the support of 3D printing, and of course, making food. I think 3D printing is enabling a lot of applications, and that's great to see. And before we dive into the panel, just request our attendees to continue to leave your questions as we proceed with this session. And if anyone has missed out on earlier presentations, do keep your eye out for updates from NAMIC, as they will be making playback available on namic.tv. Regretfully, Benny will not be able to join us for this panel discussion. Hopefully, we can hear more from Benny in the future. Meanwhile, I'm sure the rest of the panelists will engage with us for a fruitful panel discussion with their diverse backgrounds. So let's begin. Again, guys, quite interesting technology here being enabled by 3D printing. Great to see that. I'll start with Mike. And being a biotechnologist, it's great to see how the biology field has kind of revolutionized with the help of 3D printing. So there is an amazing advances which you've made with fresh technology. How far do you see in reality is tissue implants made with this technology? What's the roadmap looking like that in terms of that application?
It's a great question, Aditya, and I appreciate the chance to talk to you about it today. As we look at it, I really do think the ceiling for the technology is unlimited. As far out as we can see, we have a roadmap today in place that we believe takes us across 12 to 15 years of development to the place where we can make organs for implantation. And that's, I think, really exciting, because as we look at how we apply additive manufacturing, it really allows us to use some basic tools that can recreate the structure and function of tissue. But it's not a silver bullet in and of itself, right? It requires also understanding how the developmental biology works and what we can do to give cells and the extracellular matrix the right kinds of signals to take something that's put in place and then help it to grow and mature. It's really important to remember that no organ that exists in any animal anywhere in the world came to be just in place as it is. They grow that way, right? And so they start embryonic and become mature over time. So there's a lot of insight and input available to us to be able to leverage those techniques as well.
We look forward to the innovations from Fresh and see how it helps improving patient outcomes, because I think that's what's going to be the final objective, right? With a lot of these applications which you are working towards. And anything to add, Mike, on about your technology before I move to maybe Arthur or Daniel on different aspects?
Yeah, absolutely. I think it's really important for us to remember that the nature of what we're working on has a 12, 15-year goal. But what we do today is we work on things that have a much closer time to commercialization. We'll have products hitting the market next year, the year after that, the year after that. And that's a big part of how we approach taking this technology and building up the right to tackle a big 12-year, 15-year vision, because you can't just take one grand slam swing. You've got to be able to build a viable company to earn the right to get there.
Yeah. With that, moving to Arthur, I think it's really great to see the beautiful installations and infrastructure being created with recycled material, and that's a great upcycling activity which you're taking out. But how important is 3D printing in your activity, and what is the biggest hurdle you see in achieving circular economy based on your experience so far?
First of all, I really don't even think we should be talking about whether 3D printing is related to my industry or any of our industry, because that is just the natural norm. That is has been our norm from the way how we design, all the way how we prototype, all the way to how we manufacture. It's already a norm for us. So we have plenty of these machines. Sometimes we farm out the 3D printing all the way to in-house. Okay, so first of all, the additive manufacturing piece, I think it's a set in stone, at least for us. I think another issue where you can find that is very exciting is that what additive manufacturing does to us is what we call decentralized manufacturing. And I'm sure everybody already knows that about 3D printing. So, but for us, why in my industry is very important is because if you want to reduce carbon footprint, you want to reduce secondary pollutions in the decentralized upcycling process, you need to be able to do so with a much smaller footprint, with a more control methods, and with least amount of resources. And that by default is where we get inspiration for many of our modular machines. This is very similar to what Daniel is trying to do with decentralized manufacturing of the steak. This is the same. This is the only way to, additional to the material you use or how you farm beef, you farm marble, like in constructions, you farm marble, right? You take out mountains, you take out rainforests to get a piece of wood. You see, if you can do so with the trash that's collected locally and directly transform locally, and that is the holy grail, and at the same time create the same premium beauty and the variety that's needed for a premium product, I think that is the only way to satisfy our very selfish genes to show world domination somehow. But I think this is where I see, and the last point I want to make is all this technology doesn't matter. I think 3D printing is just part of our trend and the way how we think already from this generation of innovator. But I think as a topic, doesn't matter if it's medical device, doesn't matter if it's food manufacturing, doesn't matter if it's trash upcycling. We're all talking about in the next centuries, we all be focusing on that. This there's no like immediate next year, it must be this or that. It's just like, it just has to be this way somehow. But we are just in our, at least in my everyday life, in our office, all our engineers is always working toward that. And 3D printing, or at least additive manufacturing, is helping us to achieve that. But of course, lots of limitation with the current technology. So we're constantly modifying, both on the material side, manufacturing side, digital side. So this is still an evolving journey. And this evolving journey will last in our lifetime.
I think Arthur quite...
Sorry, we can't hear you.
Yeah, Arthur's, I think, really powerful statements there, and we wish that MINIWIZ, you grow further and are able to impact the circular economy or the sustainability activities around the world as well. So, and it's interesting to see that 3D printing is enabling that. And on that note, again, moving to Daniel, I think the sustainability of food becomes an important kind of core principle for what Redefine Meat is doing. And you made notable progress in the area of 3D printing food. What's the key factor for your success in achieving that?
Hi, thank you for asking this question. So as I mentioned in my talk, our main enabling technology that we are using in the 3D printing approach is creating the internal composition of meat. The meat is a very sophisticated natural product that till now was just impossible to recreate by the existing food technologies. That's why we see only minced meat products in the market. So for us, the biggest sustainability promise is being able to actually put on the shelf or on your plate a product that is comparable to real meat. And to do this, we need a technology that can deliver this level of sophistication, this level of internal structure, this level of manufacturing. And we found this in the 3D printing and in the additive manufacturing approach. So as you know, I'm coming from the background of Stratasys, where I was working on multi-material 3D printing for many applications. One of them was the digital anatomy printer, a product that is already in the market that is actually capable of printing human body parts, not biological, they're totally synthetic, but they have the same level of the needed level of sophistication to serve as a replacement for cadavers or animals, for example, in medical companies or in hospitals, in training of surgeons. And we learned from this experience that gathered in the additive manufacturing industry for many years already. And we took this approach and we applied this to the meat production industry, where we actually disassemble the meat into different components, and we use the multi-material additive manufacturing approach to put them together into the right structure. So by enabling this breakthrough in the product level, we can actually compete now with real meat for people who love meat, and not only for vegans or people that want some replacement, but also for people that don't want to compromise on their meat quality and that are looking for this level of mimicking, of making something that's really comparable to the nature.
And Daniel, are you also looking at 3D printing other types of food, or is just meat which is going to be the focus? So any other kind of meat in terms of seafood or those kind of areas? Are you working on those aspects of that?
Yeah, so that's a great question. We definitely look on the whole range of animal-free foods that they will replace the animal products, but we totally focus for the first stage on a whole muscle cut of beef, because first of all, beef is the highest pollution industry today, and it's the one that it's very important to provide a fair replacement for. And second, it's the most sophisticated. We know that the premium cuts of beef are the highest, very high priced product. So we have more capability there to use high-end technologies to produce these products while staying at a competitive price. And we totally understand that once we have this in our hand, and we are already actually having a product in the market, we just launched our first whole muscle cuts 2 weeks ago. So then taking this technology and actually adjusting this for much more simple products like fish or seafood, it's a natural process, and we'll go there. But making the perfect steak is our #1 priority.
Just let me jump in a little bit here. I think there's a great discussion ongoing between you and the panelists. I think while I would love to let all of you go on further, we would like to take a look at our audience's questions as well at this point in time. They have been steadily sending in and dutifully, as like you have been asking them to do so. So let's have a look at one or two of the questions, and then you can take the rest, Aditya. So there's a first one here. I understand you can 3D print a printer. Is that the ethos of sustainability in AM? Wow, big question for all of you. Anyone out there willing to take that?
Yeah, sure. Sure, I will take this.
Yes.
So printing a 3D printer is something that already happens. So at least in our company, we use a lot of plastic 3D printers also to produce many of the details that we use for our meat printers. And so we can print many of the components that we have in the 3D printer. So technically, this is happening already. But if you are asking more from a philosophical point of view, do you actually able to replace all the 100% parts in the printer by 3D printed elements, or to do so in one shot? Then definitely there's still a way to go. But it's really important to understand how advanced our approach already is. So I don't think that we need to fight to replace every last piece in this equipment, but it's important to see how we create the right tools, most importantly software tools, that allow us to design elements in a very easy manner, so that we can everyone can actually design parts for any system that is building and produce them through additive manufacturing.
Staying on with you.
Yeah,
sorry, carry on.
I hope this answered the question.
Yeah, I think I hope our audience who has posted this question is happy with that answer from you. But staying on with you as well, there's another question for you. Are there any plans to sell your meat overseas? I'm curious to try, asks one of our audience here.
Sorry, can you repeat the question?
Do you have any plans to sell your meat overseas, your 3D printed meat? And he's curious to try it.
Sure, we are doing so already. So as I mentioned, last Monday we had a launch event that we had in 4 countries at the same time. We put our products in Michelin star restaurants in Amsterdam, Berlin, and London, and Tel Aviv. And we did a live streaming between the 4 sites. Of course, due to the corona limitations, we would prefer to do this all in one place, but that's was the limitation, and we did it in 4 different locations. We shipped our meat to all these locations, and we already are building our factory in Netherlands. So we will have this year already 2 factories operating in Israel and in Netherlands, and later in other places as well. Singapore is definitely among our very favorite locations, and other countries in the East. And we can both ship ready meat from the production sites, but our long-term goal is definitely establishing local production sites, so we can minimize the shipping costs and minimize the sustainability impact, and produce the meat very close to the end customer.
Questions that you may want to take on from here?
Yeah, sure. Thanks, Mahendran. Great to take those audience questions. There's one question which which I want to ask is there's a common notion that 3D printing or AM technology is more expensive than conventional methods. So for all 3 of you in your respective spaces, as you know, the way you're working in is quite diverse. How does the technology fare in this aspect, and from the cost point of view, compared to the conventional technologies?
Yeah, I'd be happy to start. From our perspective in the field of biomedical engineering and in the manufacture of whether it's medical devices or advanced pharmaceutical assays, if we were to point our technology at things that you can make other ways, we would most likely be a more expensive way to make the same thing. And I think that's true in a lot of applications. That's part of why I think all of us here on the panel and so many folks in the additive space today really point additive at problems that can't be solved other ways, right? Because if you try to do something that you could otherwise mold or cast or other ways, yes, you'll be able to do it faster and cheaper. But we can do things that historically we've always wanted to do or needed to do, but today we can't. And so when you don't have a viable alternative, then I think the cost question becomes a different dialogue. And that's really where we focus our time and energy.
Yeah, Arthur, you want to add into that?
No, I just can't agree more. So I don't think I have anything to add.
Yeah, I would like to add that it's also important to understand that frequently when people speak about the high pricing of 3D printing, they mention universal 3D printers that are built to print any part or any geometry or any material. And then when you need this versatility, there is a price for it. But when you look on the specific application of 3D printing, there are so many ways to optimize the process, to optimize the printer. So there are multiple ways to reduce these costs, and then it becomes much more competitive with other technologies. But still, I totally agree with Mike that the conventional technologies like injection molding, like regular molding, like mixing food ingredients to make a burger, for example, there definitely will be cheaper. So there is no way, no reason to print a burger, for example, right? If you can produce it by other methods. But for a whole cut meat that is impossible to produce by other methods, you can. We are showing already that it's totally feasible from also a cost point of view to make the right solution using additive manufacturing.
Thanks. I think that definitely gives a perspective to that point. There's a specific question to Arthur from the audience, and it's more about you mentioned this in your talk about how 3D printing is contributing to the whole part. But the question is, how does 3D printed components or joints contribute to sustainability? Is the question for you, Arthur?
Wait, sorry, I lost you on the last part of the question. How do you?
How do 3D printed components or joints in your parts contribute to sustainability?
First of all, a lot of these joints that we design for the hospital, for example, needs to be tooled, right? So during the prototype and the certification phase, we need to have a quick fix to solve all that. One way to do it is that you can outsource all the manufacturing elsewhere where availability is not there. And like I said, this is or you can 3D print it yourself in your own office, and then you directly use that as part of a certification process. Then you move the whole project forward. So both on the transportation perspective of just the amount of communication and the material needed to produce that one room of component for certification, that it's already huge amount of carbon saving right there. On top of that, the material we use in 3D printing also is a lot of times we already use the crap that we have in our office, and we have a capability to make our own spool. I don't know, you just like printing meat, but we have our own crap, which is mostly PE and PP, and sometimes PLA. But PLA we try not to use because it's hard for us to get raw material to recycle them. So for us, we just use whatever we collect and we make our own spools. And the material we use to print is already our own material that we produce. So you see, that's already a complete full circle in ourselves. So I don't see how you can have lower footprint from that whole process.
And Arthur, do you, to this supply chain, do you feel any material innovation or hardware innovation needs to be made to make the process more sustainable? Do you have any inputs on that side, or do you feel it's already working fine?
No, like there's so much to improve on the 3D printing side. I think mainly it's the speed and the software. I think previous, doesn't matter as Mike or Daniel, they talk about, we all talk about the beauty of 3D printing, but there is a lot of technology hurdle also. So there's still a lot of hurdles to make it work properly. It's always, we have to print multiple times. It's always, things doesn't work. That's also part of a beauty, right? You can do like this. So there's, I don't think we're here to talk about how far the technology is from to make it smoother. I think there's plenty of innovation that's needed to make it smooth. But right now it's not so smooth, I have to say.
Okay. No, I think that answers the question. And there's another audience question for Daniel. You did mention this briefly in your presentation, but how would the texture of 3D printed meat be altered to be as close to natural fibers?
If I hear you correctly, you are asking how the 3D printing is recreating the texture of natural muscle fibers?
Yes.
Yeah, so actually the 3D printing approach is very well fit into the meat structure that it is required, because we are using dispensers that has nozzles that of a comparable thickness to muscle fibers. That's really easy to achieve. You know that in plastics industry, you can produce elements that are on the scale of tens or hundreds microns. In the muscle fibers, they are much thicker. So a fascicle of a muscle, that's the fiber that we see in the meat when we eat it, is about 2 to 3 millimeter thick. So it makes it very easy to dispense this size of elements, and that's also a reason why the additive manufacturing is suitable for us, because we can print much faster than the plastic industry. We don't need that high level of resolution that you require for other applications, also biomedical applications. For food, the required resolution is much lower, and it allows to print much faster. So we can actually extrude these fibers of the right thickness. And one of our biggest modifications that we made to the meat printing is that we do not really print a single stake, which would be very difficult to place the fibers in the right direction, in the Z direction. So we actually print a big slab of meat where all the fibers go in about the same direction along the slab, and then we just cut it into steaks. So that's how you get fiber orientation that is relevant to a real steak product. And that's how we optimize the form, the natural form that we already get from printer extruders, and we adjust it to the meat structure.
Okay. Yeah, I think that's quite interesting. I'm sure that answers the question asked to Daniel. There's one question for Mike, which is more on the future forecasting, right? So for you at Fluidform, what are the 3 main areas you think Fluidform will contribute or make an impact in, let's say, in the next 5 years?
Sure. You know, our major areas of focus today are in 3 categories of activity. So I think it's pretty easy to talk about the 3 main areas. Number 1, we talk about advanced 3D models for testing new drugs. Right. So today, of all the new drugs that go into humans, 85% of them will never see the market. That's because no matter how good we've gotten in pharmaceuticals, we're still really bad at guessing which drugs are going to be both safe and effective when we start testing them in humans. We can and we must do better. The models that we're working with pharma on, even now, we think represent a huge step forward, and we can continue to do much, much more on that front. The second area is related to the area of surgical repair. So when you think about classic medical devices, there are a pretty large swath of either bioprosthetic devices that we take from animals and repurpose for human use, or we take basically collagen and extracellular matrix and shape it into shapes that we use in surgery. Most of those are very limited because we use conventional old-fashioned manufacturing technologies. And so there's very limited ability to control the internal architecture, to induce cells to grow into them by controlling the porosity or otherwise. And so we're working right now with a number of forward-thinking medical device companies to develop new products that will be on the market in the next couple of years to really advance the field of surgical repair. These are things like, the field of orthopedics and sports med and some other really interesting areas for us.
And of course, the last area is to start to take all of the technical components that really contribute to both of those categories and to start to assemble real working pieces of tissue. So we are really excited about all three. We think all three have really, really big, significant, both human impact as well as markets. And so we're really driving all three of those forward.
Yeah, that's great to hear, Mike. And extending this question maybe to both you, Arthur, and Daniel. In the next, let's say, 5 years, what are the three main areas you would want to make an impact, or looking to focus on in the coming future? Maybe Arthur, you can start, and we can then move to Daniel.
Yeah, I think, one of the things that Daniel's presentation, where I thought was very related to what we do, is one of the area we are focusing on is definitely architecture and real estate development, because there's a scale gap. There's a scale gap between the amount of trash we produce and the application that's needed to take that trash into application. So architecture for us, or building activity, is the quickest way for us to have that scale match the trash to the application. But unfortunately, when you are doing into this, taking trash into architecture is something you buy, the most expensive piece of permanent fixtures that you buy from banks. Banks buys them when you are really wealthy, or when you want to have a family, you buy them. So this is completely pleasure-based, completely cultural-based, completely what's Daniel's term? I don't know. It's like it's cultural,
hedonistic,
right? Hedonistic, yeah. So it's like it has nothing to do with performance. It has nothing to do with sustainability, how much energy you save, all that stuff. It has everything to do with pleasure and cultural. So how do we do that? I think that is especially when we were trying to match that scale and focus in real estate. I think this is a part we need to continue to develop, and to be able to convince people to make the change without the loss of pleasure, visual pleasure or physical pleasure. Yeah.
Yeah, quite interesting point. So Daniel, you would like to add in to in the future, what's the three maybe main impact areas you feel Redefine Meet will kind of focus on?
Yeah, so our first goal is definitely to make a good competition to real meat. We do not compete with meat analogs because we set a totally new standard for a meat, animal-free meat, and that's our goal, to recreate not only one cut of meat or only one type of a specific type of steak, but to replace the whole cow, to be able to make all the cuts that we love to eat from a cow, and also then expand to other animals, to make pigs and fish and other products that we mentioned earlier. And the second goal would be, of course, to do this in a sustainable manner and to upscale the production, so that we can make more meat to satisfy the needs for all the countries that we enter to. And that will be a great challenge, because you know how what are the amounts of production for real meat. If the total market for meat today in the world is $1.4 billion, it's just enormous. So getting to the right amounts of production will be very challenging for us. I'm sure even 3 years from now, it will be even more challenging, because every step that we go further and every time we get a better product to the market, then we need to adjust our production facilities to meet the demand. And for the third goal, I would say it's being able to fully implement a data-driven approach, where we actually maximize the value of 3D printing by working with numbers. We feed the printer with numbers, right? And we get out a product we can also quantify in numbers. In our case, it's sensory panels and different measurements, physical measurements that we do on our product. And then you can actually close the cycle and run a very sophisticated optimization methodologies and techniques that today run mainly in the digital domain, digital data domain, but now we can run this in the physical data domain because the 3D printer is actually a bridge between the digital world and the physical world, and everything that you do today for optimizing, for example, advertisement or other elements in the virtual worlds, you can actually apply this to make better stakes, to make better architecture, to make better organs for transplantation. And that's a key factor that will also drive the benefits of additive manufacturing to a totally new level.
Yeah, that's great, Daniel, and thanks once again, Mike, Arthur, and Daniel for joining us today for this panel and talking about the exciting applications you're working on with 3D printing. And so that's a wrap for this session today, and we'll see Mahendran back in the studio. So thanks again, all of you guys.
That was a great session, exploring the up-and-coming emerging applications of additive manufacturing. We've heard fantastic insights on how AM can complement and enhance existing technologies such as tissue engineering, metal production, meat production, and encourage upcycling and sustainability. For the next segment, we would like to invite our corporate sponsors for an industry spotlight sharing session. They will shed light on their role in the AM industry and how you can start and accelerate your company's AM adoption journey. After the industry spotlight, we will be having a short break from 1 to 2:30 Singapore time. So do take this time to refresh yourselves. We will return to the program at 2 p.m. Singapore time for episode 2 of AM Career Talks. Yesterday, we heard from employers who are looking to hire in the AM job market. Today, we bring you a candid session with Alexander Daniels Global, a strategic partner in AM recruitment, and AM Talents to unveil the global hiring trends of the industry, as well as telling us what it is like to pivot into a career in additive manufacturing. We will then end off our summit with a final round of presentations on social impact of 3D printing. Our speakers have some really exciting experiences to share, so do join them at 3 p.m. So stay tuned and we'll see you in the next segment soon.
Ladies and gentlemen, on behalf of TÜV SÜD, thank you for joining us. I'm Beng Yang. For more than 150 years, TÜV SÜD has been inspiring trust and technology, enabling progress by managing technology-related risks and facilitating change. For additive manufacturing, we ensure the quality, safety, sustainability through our testing, inspection, and certification services. Since the inception of our AM Center of Excellence in Singapore, supported by Economic Development Board, we have supported several projects with partners to push the boundary of AM to be a reliable pillar of advanced manufacturing. We would like to share some updates, our R&D work in progress, and invite you to partner with us. In NAMIC Summit 2019, we started partnership with AM.NUS on biomedical implant quality and safety. The project is making good progress since then. We work with LTA, SMRT, Tencent Group, SUTD to prove AM as a reliable technology for real rolling stock spare parts. During the pandemic of last year, we are proud to be part of the Singapore AM ecosystem led by NAMIC to work on the quality and safety of the 3D printed nasopharyngeal swabs. To support SME and service bureaus to expand market share, we work with Enterprise Singapore to provide 80% funded program to achieve industrial-grade AM manufacturer certification. For safety of operators working in metal AM facility, we contributed to ESG's technical reference TR87 and provided trainings to local operators. We also formed partnership with Siemens AMTC with the aim to roll out health and safety training for all qualified personnel and professional engineers in Asia-Pacific region and many more. Moving forward, we have 3 R&D areas that we welcome like-minded partners like you to join us. First, digital part certification for traceability. By scanning a QR code printed on an AM part, key manufacturing process history audited and verified by TÜV SÜD will be available, enabling full traceability and a step towards digital twin concepts for Industry 4.0. Sustainability in AM powders. You have seen the MOU with MollyWorks earlier this morning. Together with MollyWorks, we will study the circularity of AM powders, carbon footprint in Singapore context, and recycled content. Third, AM-specific quality management system. The newly released ASTM 52920 is an essential step towards industrial-grade, high-quality AM production. We will continue to provide the industry with this capability. Please reach out to us if you are interested in any of these activities. Next, my colleagues will be elaborating more on 2 topics close to our hearts, quality and safety.
My name is Dan Qing. TÜV SÜD is a testing and certification body. Our neutral and independent assessments enable manufacturers to build capabilities and gain trust from end users. Specifically for AM, we build in our AM expertise in quality and also safety, as well as the sustainability topics. Right, for quality, TÜV SÜD had established a certification scheme on AM quality assurance, IAM Ready certification, since 2017. Where we inspect factories according to the state-of-the-art AM standards, such as DIN specs 17071 and ASTM 52920, to make sure that the factories are delivering a quality and consistent product and a good traceability. And also for typical certification journey for AM with TÜV SÜD, how does it look like? It will include the pre-audit, where we will conduct document review and also on-site assessments, and followed by another step, which is the audit evaluation, where gaps and areas for improvements are identified. Then followed by reporting and implementation of the improvement for gaps identified. Of course, the last step of the certification is the certification audit, where we will assess whether the organization is conforming to the certification requirements. To maintain the validity of the certification, a surveillance audit is also conducted once a year after that. We help customers to establish test plans and conduct testing of AM products, taking into consideration technology use, functionality, as well as safety aspects. We have services to qualify the raw materials properties, as well as, in some cases, the reused materials properties, to ensure that the quality of the final products are there. Thirdly, we work with AM powder makers globally to ensure AM powder sustainability and quality to create environmental benefits to the additive manufacturing ecosystem in Singapore.
Ladies and gentlemen, welcome to TÜV SÜD Additive Manufacturing. My name is Balu. Because of the inherent design freedom and the ease of fabrication AM offers, more technology adopters are coming to the additive manufacturing space. Even though AM has the capability to manufacture almost anything from small plastic gadgets, such as keychains, mementos, spectacle frames, etc., all the way until fully functional metal parts, like implants, turbine blades, or even 3D printed rocket engines, the growth is more pronounced in the metal AM sector. As a result of this growth, more and more AM facilities are being built globally. But this growth also brings the issue of additive manufacturing safety. As the technology utilizes some of the potentially hazardous hardware, materials, and processes, safety of AM facility is on top of the agenda for many stakeholders, including OEMs, facility owners, and even insurance companies underwriting these facilities. Due to the lag between technological developments and the science of safety in additive manufacturing, you need to make sure that the new facility is safe to use before commencing operations. Unlike its traditional manufacturing counterparts, such as subtractive manufacturing and formative manufacturing, additive manufacturing has a distinctive hazards and risks associated with it. Some of them include material hazards, equipment hazards, and facility hazards. AM requires substantial investment in terms of machines, materials, and manpower. A typical single powder bed fusion machine setup will easily offset more than $1 million, and no one in their right mind would have such an investment wiped out just because of ignorance or carelessness. Having seen the hazards and risks, the next question is how we can bring safety into AM facility. Well, the short answer is by integrating the islands of expert knowledge available today. It involves combining the expertise of important stakeholders such as AM equipment manufacturers, material developers, user communities, research and development institutions, regulatory authorities, safety certification companies, standards organization, and so on. Convert that expert knowledge into a set of guidelines and actionable practices. Create a safety program based on those guidelines and regulatory requirements. TÜV SÜD has developed health and safety certification of AM production sites to meet these demanding requirements. Health and safety certification of AM production site. TÜV SÜD Singapore has certified Digital Cantech Company Limited Taiwan for health and safety in additive manufacturing. Fully developed by Singapore's Center of Excellence, the certification scheme centers around PPP 10998:2021. This TÜV SÜD normative reference defines the HSE requirements of additive manufacturing production sites that employ powder-based AM technologies for printing of parts. So we have come to the end of this presentation. Thank you for joining us.
Yeah, hello everybody. Welcome to that presentation in TRUMPF additive manufacturing. My name is Rainer Grünauer. I'm the director for sales and application for additive manufacturing here at TRUMPF, to give you some insights about additive manufacturing and the current status at TRUMPF. You see it already here, TRUMPF Industrial Additive Manufacturing. We are calling it at TRUMPF. Everything what we do, doesn't matter if it's an additive manufacturing machine or it's a laser cutting machine or a bending machine. Our goal is always to develop machine tools which are for industrial use. For additive manufacturing, this is one of our technology fields where we think and where we are sure that this is actually an additional technology required to give competitiveness for our customers in the future. The year 1999, we started an initiative of AM activities in cooperation with the Fraunhofer ILT in Aachen. 2003, we had the first machine, which you actually can see here. That is the so-called Fluidform machine, our first LMF machine at TRUMPF. And unfortunately, we were a little bit too early for the market, and only a few machines were actually sold. And as we are a standard machine tool producer, we actually need at least 40 to 50 machines a year per product, and that was not at that time. So we stopped the activities in additive manufacturing. What we have not stopped is actually always looking actually into the laser metal deposition. So this is something where we are still developing over the years, and which we are still offering, or which we're offering to our customers, LMD systems for integration, or also for our machines itself. I will come to that later as well. 2014, we actually entered again into additive manufacturing, and we have started a joint venture together with the company Sysma, which is close to Venice in Italy, and together with them, the joint venture is developing our TruePrint machines and is also producing the TruePrint machines, the series 1000 up to 3000. You see here then already 1 year later, we had the TruePrint 1000 actually in the market, which is the best-selling machine of TRUMPF at the moment, as we have the machine already 6 years in the portfolio. 2017, a bigger machine was introduced. That's the 2000 TruePrint 3000, and in 2019, the market release of the 5000 machine, which is a product from our headquarters, which is not developed in Italy, that's developed in Germany. And in 2020, we have the market release of our TruePrint 2000. Well, a little bit of technology comparison of laser metal fusion and laser metal deposition. You see on the left side, the laser metal deposition, which is a productive method of repairing and coating, generating components. Actually, you see a little bit the comparison with these stars, which we have put there. On the other side, you see the laser metal fusion. It's a very precise method for generative fabrication of complex part out of a powder bed. And you see here, left and right side, as I mentioned, the comparison. We see that LMF is a little bit slower, LMD is a little bit faster. It's more accurate on the LMF side than on the LMD side. Also, the service quality is better on LMF as compared to the LMD, much more rougher surfaces we actually have on the LMD side. But important for us is actually that these two technologies are under one roof at TRUMPF, and we believe actually in both technologies for each application. Additive manufacturing, what we are looking into in my team is actually, we are talking about the right side, so the laser metal fusion with the machines we have actually just seen before. Maybe some more information about the machines itself. I said it already, we have in total 4 machines developed over the last 6 years, which is a quite unique thing, as normally we need 3 to 5 years to develop new machines. But of course, with the help of this joint venture, and we were able to be able to a little bit faster with the machines to the market, and especially for the TruePrint 1000. In total, we have around 400 machines worldwide installed at the moment in all important countries. We are using our subsidiaries. We are everywhere in the world in with own subsidiaries where we, via this, we are actually selling these machines. The TruePrint 1000, a very compact and robust 3D printing machine with a build cylinder of a diameter of 100 and the height of 100, available as a single laser and a multi-laser with 200 watts with 2 different beam diameters. We have special options on that machine. We are focusing very much with that machine in the dental market, as well as R&D market, but also our machine tool customers, when they would like to start with additive manufacturing, that is actually the right machine. The TruePrint 2000 with a bigger build size, we are always talking about a round build cylinder, 200 millimeter times 200 millimeter. Also here, single laser, multi-lasers available, so 1 or 2 lasers, 300 watts maximum, the beam diameter of 55 micro. And here this machine is able to do a preheating of 200 degrees, and it's possible to have an inert powder handling system here. The TruePrint 3000, it's a flexible solution for us. It's a beam build cylinder, diameter of 300 millimeter and a 400 millimeter height with a 500 watts laser, also single and multi laser, so 1 or 2 lasers with 80 micro and also preheating 200 degree. And coming to the 5000, that's our flagship machine with the same build cylinder size than the TruePrint 3000. But here the possibility is to have 3 lasers in total, 3 times 500 watts, and a preheating option, which is unique in the market, for up to 500 degrees Celsius. I mentioned already the industrial use of our machines is a very important topic for us, and for that we have developed the machine in a way that they can actually be used in a very efficient way. And for us, then it's important to have a so-called external powder management, which you actually can have for the 2000, 3000, as well as for the 5000 machine. What does that mean? The industrial part and powder management, how we actually call it, is actually the components which we have here is the so-called unpacking station, the powdering station, sieving station, powder silos, and the electrical lift truck. These are the components of our industrial part and powder management. So how we think is actually that the machine must run. That means after a build job actually has finished, we are going to take out the cylinder, including the build job, which is inside, out of the machine. And we have already prepared the next build cylinder. We have also prepared the supply cylinders with some new powder, which we directly place into the machine. So that means after 30 to 60 minutes, our machines are ready to start again. So there is a possibility for the 2000, 3000 to unpack inside the machine itself. But if you want really to use the machines officially, you need to take it out, even with the 500 degree. When we are talking about 500 degree, we also have a station where where we are doing the cooling of the cylinder in a specific atmosphere and with parameters, so that the cooling is done actually properly of the cylinder. So important here for us is that we are doing all the things which are not to be done inside the machine, we're doing actually outside of the machine. And this enables also contact-free powder removal of build jobs, as well as storage and transport and sieving of metal powders. This is a very unique topic. As I mentioned, high productivity and profitability, short throughput times of large powder volumes, high degree of cleanliness within production environment, a very high safety and a great flexibility. And this area you also can see actually how we think. This is not only for our additive machine. The same is true for bending machines, punching machines, laser cutting machines. We always think in how we can increase the productivity and profitability of our machine. And this is one component out of it, where we are also quite proud of it. We are working over the last years in two topics mainly. One topic was the robustness of the machine itself. We're talking about the topic reproducibility later on. And another topic which is also very important for us, where we see a high demand, is monitoring solutions. And here you see our product landscape, what we actually can offer at the moment. And these things, step by step, we are increasing and we are coming out with more and more solutions in regard to monitoring. We have on the one side here the machine, where you see the process monitoring, which we actually can offer, powder bed monitoring, where we make from each layer a picture which we are storing on the HMI, on the IPC of the machine. We are offering here as well so-called melt pool monitoring. So by using a scanner, we are scanning actually the melt pool situation, so how the machine is actually performing. We're talking about condition monitoring, so the status of the machine, and as well the so-called performance monitoring. And all these informations are either can take out actually by the OPC-UA monitoring interface, or by a monitoring file interface, and via the use of the TrumpF monitor, we can actually, the monitor analyzer, we can actually analyze these informations which we are collecting when the machine is doing the job actually, and doing the laser melting of the powder. So this is something which is very important for us. So especially when we are talking about certificate areas where you need certification and qualification of the machine and the process itself, it's a very important topic, and we have really worked a lot on that topic within the last 2-3 years. Here we see the single solutions which we actually can offer just as a quick and rough overview for you. We see here the sensoric systems, as I've already mentioned. We see here the so-called melt pool monitoring, where we have here using actually a scanner to analyze the melting of the powder itself, and which we are then storing these informations which we are generating out of that. And finally, via the monitoring file interface, it goes to the monitoring analyzer, where all these information are stored and can actually be analyzed in a specific way. But also these information are going to the HMI, so directly the operator on the machine can get those informations which are actually collecting on the machine control unit itself. We're talking about the powder bed monitoring, where we are doing, as I mentioned, for every layer a picture where we actually can see some defects, for example, because of the coater has a problem and these kind of things. And of course, as I mentioned, condition and performance monitoring. Is there enough gas pressure? Is there enough oil? Is there enough, these kind of things? We do here measure, and via the OPCOA and the TÜV monitor, this can be actually shown even on an iPad or a computer itself, even from home. You can actually see how your machine is actually performing. So these are the very rough information about the topic. More information, of course, from our experts are available, but for me, the most important topic is actually to address in that presentation that monitoring solutions are a very important topic, and also we will do some more development in these fields within the future. I hope I was able to give you a quick overview about additive manufacturing at TRUMPF. And of course, if you need some more information, please do not hesitate to contact us. Thank you very much for listening. The most important thing is stay healthy. Thanks and all the best.
Hi everyone, my name is Guillaume Mahara and I'm a project engineer at Cetim-Matcor, which is a mechanical technical center based in France and Singapore. I myself am based in Paris. My colleague Aish, who's based in Singapore, and I would like to talk to you today about how AM enables new applications and the impact of these applications on our society and the environment. We'll briefly first tell you about Cetim-Matcor's activities, and then we'll focus on two concrete impacts of AM, which are the new cost models it offers in medical applications, for example, and then in material innovation, which can lead to decarbonization and cleaner energy. So as I mentioned, Cetim-Matcor is the French Technical Center for Mechanical Industries, and it was founded in 1965. And that was arising from the need of mechanical engineering companies to conduct mutualized and collaborative R&D in order to stay competitive. The core of our mission is to accelerate the development of technology by conducting R&D activities, as well as advanced testing and technology transfer towards the industry, and also standardization efforts. We have a wide range of companies that we're helping, from automotive and aerospace to medical and luxury. And what we help them with is to successfully implement their technological roadmap. As you can see on the screen, we have a deep expertise in all mechanical-oriented fields, starting from fatigue and assembly to NDT and more. Metal additive manufacturing is also a key topic that we've conducted research on for over a decade now. As I mentioned, we focus on mutualized research and development, but we also dedicate a lot of our time and efforts in transferring that knowledge to companies through training, like webinars, as well as consultancy work. Now, the majority of our activities has been in France historically, with 23 facilities in France, as well as our headquarters, which is near Paris. We've also established an international presence throughout the years, first of all in Africa, with sites in Morocco and Tunisia, as well as Asia, and Our deployment hub in Asia is in Singapore through our subsidiary Matcor, which is a company that's recognized for its mechanical know-how and expertise. We also have a very strong relationship with the KMTL company, which is an equivalent of Cetim based in Japan, in order to deploy our activities in the Japanese and Korean markets. So now I'll share a short video with you from our Director of Operations.
Additive manufacturing describes technology that builds 3D objects by adding layer upon layer of material, plastic, metal, concrete. Cetim has been fully involved in the development of this technology for many years. For example, metallurgy, it takes also advantage of years of experience on mechanical process such as casting, welding, heat treatment, machine tools, robotics. France has a key role to play in this international competition on this sector, as stated in the document French National Roadmap on Additive Manufacturing. But this document also highlighted the need to mutualize research and development. As a technical center, it's our role to promote this mutualization. That's why we are involved in different R&D initiatives at regional and national level.
Guillaume, as a production technology, additive manufacturing enables two main disruptions in applications, through design and material. The new production technology allows more complex parts, for instance, more diverse part functionalities at reduced costs. The new process also fundamentally changes the material structure, so innovation is possible in alloy development, optimizing the performance from each component. These disruptions will have profound societal and environmental impacts through the emerging applications. Support innovation decarbonization efforts, access to affordable healthcare, and reduce our energy costs, just to name a few. AM also allows for full customization at low cost, such as medical implants and instrumentation, because there's no cost for tooling or other hardware to change a manufactured chip. There are only digital data changes, and changing a few bytes on the computer is a negligible cost compared to manufacturing a mold. This enables affordable healthcare for the masses, both in metal and plastics. Cetim has successfully worked on industrial medical applications such as the orthopedic implant, which conformed to the standards of ISO 13485, and the digital metal dental instrumentation, which was ISO 10993 certified, confirming that it was safe for medical applications with minimal biological risks. Both of these case studies had proven cost reduction and even lead time reduction in the digital metal case study, indicating that patient-specific products can be cost viable for everyone. AM also enables cost-efficient part assembly redesign, which drives down the cost and the performance up, opening up new markets. For example, this locking element case study done by Cetim involved the redesign of the parts for the new production process. The design was optimized for the production process to reduce cost drastically. By taking advantage of the additive manufacturing process characteristics to increase productivity, and by maximizing the volume usage, this leads to higher throughputs and reduction in cost per parts. Cetim also worked on optimizing the topology of the aerospace pivot, where it was redesigned for the new production process. It was designed for the functionalities rather than the ease of manufacturing, same as the GE fuel nozzle shown earlier. Hence, design for additive manufacturing is more flexible compared to conventional manufacturing due to its limitations such as machining. Improved part properties and reduced assembly and reduced cost from the freedom in design is all thanks to additive manufacturing. AM also enables revolutionary sustainability improvements that pave the way for a decarbonized future. We can achieve unique microstructures through advanced process control, reduce material waste, reduce assembly complexity, and increase part durability. For example, we can control the microstructure to optimize and tailor part performance just like the turbine blade, or actually process new high temperature resistant material. This allows higher efficiency in energy generation and therefore a lower carbon footprint and more affordable energy. Cetim is working on R&D for advanced materials such as metallic glasses with extraordinary strength and high resistance to heat, wear and corrosion using laser power-based fusion technology. The main key takeaway is that as a new production technology, additive manufacturing has not only changed the manufacturing sector, but has also far-reaching consequences on the society and the environment by opening new markets through drastic cost reduction in crucial areas such as healthcare and decarbonization through material innovation. Cetim-Matcor in this regard has successfully shown how these solutions can be applied to these industries, and we are really excited to continue on this path through collaborations worldwide and ensuring our expertise to accelerate industrial acceptance of metal AM, especially in APAC region. Thank you for your time and thank you for listening.
Greetings. My name is Rajagopalan Vardarajan. I work for MSC Software in Singapore, a business unit of Hexagon. On the day number 1, that is yesterday, I spoke about the end-to-end additive manufacturing software solution from Hexagon. Today, I'm going to talk about the Hexagon end-to-end AM solution for healthcare. Something which can make a difference to the human beings and also to those people who are physically challenged or with some accidents require a medical implant. Let me introduce you Hexagon. We are a 4 billion euro company focused on autonomous solutions. We committed to innovation. We have more than 4,000 employees work in R&D to improve the solutions we have. And we are driven by purpose. We bring in efficiency, productivity, and quality, and we have proven consistently. It doesn't mean that early 2000 we were a 500 euro company. Today, a 500 million euro company. Today, we are a 4 billion euro company. Thanks to all our customers, and we have grown and we have given the results consistently. What does it mean autonomous? Way back in later part of the 17th century and early 18th century, there were a lot of mechanization happened, and that led to mass production. Then we had automated process, and today we have hyperconnectivity, leading to a lot of data. So we have automated solutions, and we have hyperconnectivity with a lot of data. Today, when you put the data to work with using the artificial intelligence and machine language, then what is known as the autonomous solution, and this is where Hexagon as a company is a leader globally. What we do, we fuse the virtual world to the physical world. On the left hand side is the physical world, where Hexagon has got the world-leading, globally leading sensor solutions. Basically has got all the hardware and also those related to the solutions and the software solutions related to the hardware. And we have globally leading various types of software solutions, and we combine and fuse the physical solution to virtual solution, fuse together to lead into the autonomous solutions. Interestingly, 95% of all cars produced today use Hexagon technology. One way or another use Hexagon technology. 90% of all aircrafts, 75% of all smartphones produced, all the electronics items and also the household items, they all use various Hexagon technologies. And 80% of the orthopedic implants, this is what I'm going to explain with one example, is also produced using Hexagon technologies. MSc software, today we are called Design and Engineering. We are part of Hexagon's Manufacturing Intelligence Business Unit, comprising of Design Engineering. This is where we do all types of software simulation solution, all the way from structural analysis to manufacturing process simulation. And we have the production software, basically the CAM solutions, and metrology is the inspection devices and the software solutions associated with this. Today, Hexagon is the only company today which has got the entire CAD, CAE, and CAM, and also the quality solutions all put in one single environment. So this is the unique positioning in the world today. And we are going to talk today about the manufacturing process simulation, which is wherein the additive manufacturing is a part of it. When parts are made with additive manufacturing, everybody knows that there are so many issues can come. What could be porosity, first time right, the cost of manufacturing trade. There is a metal part can be manufactured, polymers can be manufactured, and the defects can be external, defects can be internal. There are many other things, challenges related to manufacturing simulation. And when you talk about additive manufacturing, there are actually 4 steps involved. One is a design and engineering, wherein you, from the start of design and optimization, then after that you 3D print it and you remove all the support structures to get the part what it is supposed to be. Then you do the quality inspection that includes the external and also internal inspection, and then comes to the service life. When we talk about medical implant, someone at the age of say younger at age around in the middle of 20s, they get a replacement. It could be a hip replacement, it could be a shoulder replacement, and this person is going to live for another 60 more years. Whatever the implant goes into the body has to live like another say 60 years or 40 years, whatever this is what we call as a service life, or in the engineering sense it's called fatigue life. So today Hexagon is in a position to do all the way from design engineering, manufacturing, quality inspection, internal, external, and all the way to the service life. All put together, we have the right solution in this place. When we talk about the healthcare and talk about the medical implant, there are so many processes involved. The first step could be do a CT scan. Somebody is involved in an accident and we are going to do a hip replacement. The first step is to go for this person goes for a CT scan and collect the scanned images and create the 3D model from the scanned image. Then after that, then decide whether it's going to be a metal implant or it's going to be a polymer implant. You decide on this, then you build the process of additive manufacturing, before you take it to the 3D machining, 3D printer. Then goes through the 3D printing and manufacturing process. Finally, go through the best way to manufacture the whole the 3D printed part. Then you go through a validation process in which it goes through an external dimensional measurement, at the same time internal, the internal of the printed part. Then finally take it to the last one of once again CT scan it and also check for the life of it. So this is the entire process end to end. On the below, on the one which shows the different solutions which Hexagon brings on to the table in making the additive manufacturing. So these are all the workflow stages. It's a simple one. I'm going to show a video of a hip replacement, a portion of the hip replacement. There are 8 different steps. These are all the ones starting from the CT scanning of a patient, and the last step is the ready to use, and the description of the workflow. On the right hand side is the Hexagon solution. You will see that there is no gap in between end to end of the entire workflow. So I'm going to show you a video. So the one which I explained you, the entire stage, all the way from MRI, CT scan, and to create the CAD part to 3D printing and finishing of the whole thing, validation, quality, application. This is the big picture of the workflow. the first step is to create, this is the 3D scan. Okay, this is the part, this actual cross. Okay, the patient is there and the CT scan is working on it to capture the internal, okay, the bone structures. Okay, you know, after you create the one, it has got all those muscles and blood vessels and all those things. They are all removed using edited, and finally created the scanned image leading to a 3D portion. This is the hip of the one, and this is the portion of the implant which we want to do. So you can see that this is the one which is the polymer based implant, okay, and this is here in the software we are going to simulate the implant, whether it is, you know, after you manufacture it, it's okay or not. So this is the actually 3D printed part which is getting manufactured based on the simulation one which we have design optimized. And now this is it's a build by build, the part is manufactured, and then once it is done, we are going through again once again scanning for the external inspection. You can notice that we started with this and we created, now you can see that, okay, we are creating the entire data into the plot point of data, and then we recreate the CAD geometry and compare, is this the final one, and we can fit onto the patient one. Okay, so this is how we help onto the Hexagon's unique solutions for healthcare and product lifecycle innovation. Yeah. Thank you for watching. For more information, you can drop an email to this email, and we'll be happy to get back to you for more details. Thank you so much.
Good afternoon and welcome to the second episode of AM Career Talks, coming to you live from the Global Additive Manufacturing Summit 2021 in Singapore, the largest flagship AM summit in Asia Pacific. What can I say? I'm your host, Mahendran Reddy, the head of ecosystem at the National Additive Manufacturing Innovation Cluster, or NAMIC. In the next 30 minutes, dive into insider perspectives on the latest hiring trends in Singapore and beyond, and the exciting career journeys of our AM talents. Additive manufacturing technology has been a game changer, as all of us know, right, for the global manufacturing industry. 3D printing today is fast disrupting the way we design and produce things. Largely used for rapidly prototyping in the past, 3D printing is increasingly being used to produce high-performance end-use parts for many industries today. These include industries from biomedical, design and building construction, precision engineering, electronics, aerospace and marine and offshore, to clean technology. AM is a fast-growing industry. The global market size is forecast to reach over US $51 billion by 2030. And this is actually 4 times the current US 12 billion market size in 2020. In Singapore today, the government has set aside $35 billion over the next 5 years for research, innovation and enterprise. A portion of this will be allocated to accelerating the AM industry. This is in line with Singapore's vision to be the manufacturing hub and a global Asian node for technology, innovation, and enterprise. And today we are happy to have with us here Loxley Graham, Head of Europe and Rest of the World from Alexander Daniels Global, joining us from the UK, Birmingham to be precise. We also have Lin Han, Ambassador from Hyperganic, and Rahul, Additive Process Engineer from Beam. Our guests are from the AM industry and are joining us to share their views. Just a quick one on Alexander Daniels Global, or ADG for short, is our strategic international partner for recruitment. They recruit talent exclusively for the AM and 3D printing industry. They can help our Singaporean AM companies to expand overseas, such as in Europe and North America, and also Singaporean talents who want to take on global or domestic roles. All right, so enough of all of that introduction. So all of you guys are ready, I suppose. Rahul, Linhan, and Loxley as well. So let's quickly dive into the questions that I have all prepared for you. I want to get into some good conversation. So Loxley, ADG partners with some of the biggest names across the AM industry like HP, 3D Systems, and the SLM Solutions, among many, many more, right? Can you just share with us what are some global developments and hiring trends that you're seeing today?
Yeah, of course, no problem at all. So this year we've seen a lot of acquisitions in the industry, with companies like Desktop Metal making several purchases and several major investment funds getting involved there into startups there by VC players. We've also seen a number of companies going public through mergers, and this has resulted in a lot more interest in the industry. Talent is becoming more and more scarce, with the requirements by companies changing and the understanding of what is available to candidates becoming clearer also. This is starting to result in a large demand for talent by companies, and being competitive in salary and roles is key to enable successful hiring. Demand across all disciplines is happening, but a big focus on software and applications is something that we've noticed over the past sort of 6 to 12 months.
Yeah, I mean, with this acquisition, they're definitely looking for talents with multidisciplinary skill sets, right?
Yeah, there is that case. I think there's a mixture of a need for multidisciplinary skills alongside also skills being brought from outside of the industry that would be able to help to overcome some of the challenges that exist here in production and manufacturing, namely scaling up additive now, moving away from prototyping into serial production. And organizations and people who can help organizations to move in that direction are definitely being highly sought after.
Yeah, so I mean, manufacturing, as we know, it's quite big and it's quite diverse, but AM, it's quite a niche space. So how easy is it to find AM talents for this space?
Well, I would like to say that it's quite difficult to find talent in this particular space. It does take a real niche focus on this industry and this area to be able to help companies to find the right people. I think also understanding the technology, understanding the industry and some of the challenges in adoption that exist there also really help us to be able to identify the right people with both the hard skills and soft skills to be able to make a positive impact on organizations.
I mean, you are involved in helping companies find the right talents, and also talents find the right company as well. So, what kind of roles are there that are kind of that just spring in your face that you say, hey, we've got these quite a lot or not so many of? What are you looking at? What do you see?
Well, I think it generally depends on location, but of course there is always a strong pool of talent in the area of sales and marketing in this industry. I think a lot for over the years we've been able to build up quite a extensive pool of talent in this area. But alongside this, areas like design, applications, process engineering, product engineering and management there as well are some of the other areas where we see a large amount of demand. Also now going more into software, and there's also as well a real focus on service also. So really just helping to support the entire ecosystem of not only installing and utilizing this technology, but also working on the design side and helping to deliver parts there, going from prototyping into that serial production area, as I mentioned earlier.
Yeah. You are pretty much in the business of helping companies or talents look for jobs in the AM roles. But from your perspective, why is someone looking for a job or a career in AM? Is that highly sought after, or what do you think?
It's an interesting situation at the moment. I think that there are a number of people that work in similar industries that see this as the future. So people who work in precision machinery, who work in investment casting and other processes of that nature. These people are quite interested in this technology. They're having the opportunity to see it at work and getting to understand more and more about this. So there is a real interest there. Also, the fact that additive manufacturing is a key component to Industry 4.0 and digital manufacturing, there is also a lot of interest from that space also for people that see the future of automated manufacturing and how additive manufacturing could be a key part of that. So there is a large amount of interest now growing in the market, people looking at opportunities in this industry from outside of the sector, but there is still realistically a lot of movement from people that are already bought into the technology, as opposed to maybe people coming from outside of the sector still at this time.
Yeah, well, currently, I mean, there are courses and at the undergraduate levels and even postgraduate level in AM being run, but not too many, I suppose. But having said that, how can a fresh graduate get started in AM from your perspective?
I mean, in an evolving world there, which would move more towards Industry 4.0, being part of the AM community is a great way to future-proof your career. The technology is becoming more and more integrated into manufacturing supply chains and is very impressive in filling the gaps during the pandemic. For graduates, there are a lot of courses, as you mentioned, and opportunities to get involved with AM, not only with the original equipment manufacturers, but also end users. So yeah, I think to answer your question though more directly, how can a graduate get more started in this industry? As you mentioned, there's a lot of courses now that are focused around this technology. Alongside this, there are also opportunities for internships in the industry as well. But I think what's great about Additive is there's a real strong community. There is a community that's very welcoming and always looking to bring new people into this sector as well. So finding mentors, finding people that are willing and able to help you to understand more about the technology is something that I would suggest that people look for and try to gain the opportunity to be a part of.
Yeah, I mean, today we also have Rahul and Linhan with us, who are talents in this job, but we'll come to them in a short while. But I mean, we're still talking to you about how, professionals, who are already in the job, mid-career, for example, if they want to pivot into AM, what do they need to look out for? What is required of them? Is it a mindset or a skill set? What do you see?
Well, I mean, for experienced professionals, the main question is where your conventional manufacturing experience can help to overcome the challenges that AM faces. The market for talent is quite competitive in the OEM space, but due to existing salary structures, this can be more difficult for end users. So I think for people looking from outside of the sector, how can they fit in? I think, if you've got experience in injection molding, there are a lot of similarities to processes like binder jetting, where you would be able to take advantage of that with your previous experience. Of course, there's areas like DED, where if you're experiencing advanced lasers, again, you can make that transition across. There are people who work in material science there for conventional industries as well that would fit very nicely into resin-based printing and plastic and polymer-based printing. So I think it's really just being very mindful of what you have done previously and how that would be able to be applied to this industry. And in most cases, there are opportunities for that to happen. Of course, it's just being able to be guided, hopefully by somebody like myself or others in the industry that would be able to suggest where those opportunities could exist.
Yeah, so Loxley, you rightfully said. I mean, our talents, the job seekers, do look up to professionals like you to guide them to get to the right job and even to the salary scales. Right, everybody is trying to go up the salary ladder. What do you see? How competitive is the AM job market today in terms of the salaries that they pay and compared to something similar in manufacturing?
Yeah, I would suggest at the moment additive manufacturing is still very competitive in comparison to other industries. I think the only sort of sectors where I generally see it being sort of outpaced in terms of salary would be the IT and software worlds there, where obviously salaries can be very, very high because of the niche skills that are required in that space and the ability to transition from sort of one sector to the other. But in general, in comparison to the industries where you may say 3D printing is competing, additive is very competitive on the salary front. As I mentioned, though, that with the adoption rate of the technology increasing, though, I think that is starting to normalize more with other industries. So we are now starting to see salaries in the sector become more comparable to, say, CNC machining or precision manufacturing. But at the same time, there is still the recognition that this is a new industry, that this is an industry that still requires a lot of experience and help to grow. And as a result of that, people are compensated adequately for that experience.
Loxley, fantastic. A lot of good insights there that we're just hearing from you. We're just going to put you on hold for a second. We're going to just pivot our attention to the two young gentlemen here with me. Both of them are already in the AM career. So I want to just jump to you, Lenhan. Yeah. You are a fresh grad. Tell me a little bit about yourself. You have a real interesting job at Hyperganic as an ambassador. Tell us a little bit more about that and what you do.
Yep. So maybe I start with where I am at currently. So Hyperganic. Hyperganic is a deep tech startup, if you haven't heard it from the previous session with Pauline, that encode human knowledge into computer algorithms that create objects, be it parts, structures, or entire machines that are as complex, but as functional and sustainable as nature. So that's what we want to do. And my job as an ambassador is really to understand the different business units from communications, business development, and even a little bit of a technical side to really package it to pitch to universities and companies for them to adopt our platform.
What is your background? I mean, what's your field of study?
Oh, okay. I'm a little bit of an oddball. So I did Polytechnic, which is like a technical high school over here. That's where I did international business. Yeah. And then for uni, I actually focused on communication studies. But then I pivoted into more like a data science sort of a background already.
Yeah, so you've got a very interesting background. So why AM?
Oh, well, okay. So, funny story. So I've been actually quite involved in the startup ecosystem in Singapore. Helped a couple of founders around and actually did my own educational technology startup. And thereafter, at my final year of studies, I took an internship with a Chinese-based innovation and Chinese-based acceleration and corporate innovation firm called Xnode. So Xnode does corporate innovation programs with a lot of the big companies like TÜV SÜD and one actually research institution of A-star in Singapore called Advanced Remanufacturing and Technology Center, I think. So back then, I was completely new to manufacturing, but because of that program, I was managing it. I was matching between the problem owners and the problem statement owners and the startups who are going to solve these problem statements. I really got this very insightful sneak peek into the technology, and AM just really connected with me, resonated with me.
Yeah, so it's something that is evolving, and you create your own destiny, right? In this sense,
yeah,
and that's what AM is doing, and especially your algorithmic solutions at Hyperganic is exactly what that's results are coming through that, right? As what nature meant it to be. Am I right to say that?
That is very well put. So we try to give people a blank slate for them to mathematically frame different engineering challenges so that they can build particles just like how nature does. So exactly like digital evolution is how we call it.
Right. So they're from digital evolution to career evolution. Rahul, I want to just jump to you now. So you've just done a big mid-career kind of switch. Would I say that? You know, in your career, you've been. When did you just come into AM? Can you just tell us your journey a bit?
Right. So, I mean, like Linhan, I might fall on the traditional end of the spectrum. I've been an engineer through and through from the early stages. So, I used to work in a manufacturing lane in a semiconductor company. I moved to AM in an academic setting in 2016, and I spent about 5 years in academia. So my role there was to apply the academic research to industry applications. So bridge the gap between what the research institutes and academics were doing and apply that to industry problems in additive manufacturing. So
that's very interesting. So, you know, we've got a fresh grad here who's just jumped straight into AM, and then there you are. Tell me a little bit about how you're evolving from, you know, knowing the fundamentals of AM from in an academic environment and coming into industry. How has that helped you, and how has it helped you grow further, you know, in the industry?
Yeah, I think the time spent in academia, I realized there was a huge gap between what kind of research was being done in AM, which was really early stage, you know, like atomic level stuff. And the gap was not only in terms of like how robust the process needs to be in order to materialize something, to put it out onto a real product, but also the commercial viability. Like in an institution or in an academic setting, people don't worry as much about, you know, what you're making money or making a good business case. Whereas once I've moved to the industry, everything that you do has to make business sense. I mean, money doesn't come from research grants, but rather, you know, you have to add real commercial value to it.
Yeah.
So
I mean, your goal in the research is really to find, you know, to do R&D and find new IPs and so on, and eventually commercialize that.
Right.
However, here it's like bottom line driven in a way, right?
Right. So yeah, what we do really has to make money within, you know, a foreseeable 3 to 5 years time, rather than in research it could be a decade later. Yeah.
Yeah. Well, yeah. It depends on what levels of research are you doing, and which TRL levels you're doing these research in, right? Having said that, Loxley, just come over to you in a quick question here, because we've got two young men here in two different profiles. I'm sure you have seen such requests also to, you know, find a job or, you know, a career shift or move. How do you guide you know, such entrants in the market?
Do you mean in terms of somebody transitioning from academia into the industry, or just in general?
In general, or a mid-career change, someone who's not even doing AM and now wants to try AM. What would you say, and how would you guide them?
Yeah. Well, my advice for that would be, it's a sort of a mantra that I use with most candidates that I speak with. It's to generally think of three things, which is what have you done? What do you want to do, and how do you plan to do this for your next employer? This industry requires highly motivated and forward-thinking professionals coming into it to help to take the technology to the next level. This really requires people who can think critically of the process and look for the best use cases to ensure we do not repeat the mistakes of the past. So that would be some of the main things that I would suggest, is to really reflect on what you have done, what you want to do, and how you would do that for your next employer. If you can answer those three questions, then generally an opportunity can be created for you within this sector.
And you also help companies set up, you know, from going from one country to the other, setting up their businesses. Maybe just share a little bit about that, and then how you you know, consult them in looking for the right talent for the kind of job, kind of businesses that they're trying to set up in AM.
Yeah, of course. So there's a number of cases where we have supported organizations moving from one continent to the other, of course, expanding their operations in a continent. So, for example, a number of companies coming out of the Asia Pacific into Europe, helping them to either find the right person to enable their distribution channels, or of course, they're helping to set up technology centers and other initiatives. The way in which we generally look to do that is to understand the business, get to understand the culture of the business, their plans moving forward, how they plan to grow, and then really look to identify somebody who would share that same methodology and mindset. In reality, a lot of this industry, like all industries, is about having the right people as part of your team, having that right mindset and that right cultural fit to be able to grow together and to build the team together. And that's something that we really focus on, alongside also helping to identify the talent and the skills that would be able to really help the business to put strong foundations in a country or continent there. So yeah, that's generally our strategy, really marrying up the personalities and the mindset of the businesses alongside identifying those skills that can really help an organization to grow in a particular territory.
Yeah, I think that's, I mean, what we are trying to do is to grow our ecosystem. We are trying to bring in, international companies to set up base here in Singapore, hire talents like Lin Han and Rahul as well. But at the same time, we also we are hoping that we will also use Singapore as a base to spring to other potential countries, and that's where what you just explained would be really useful for our companies who are trying to go into these new markets.
Yeah, for sure. And I think it's fantastic, this sort of initiatives that exist like NAMIC there that are helping these organizations to not only be able to make the right contacts on the ground there in Singapore, but also to have that base and foundation to be able to expand further into the Asia Pacific region. And I think as we go forward now, and as we see more and more of the startup organizations in Europe and North America need to be able to enter into this market, there is a great opportunity to do that through yourselves and through these initiatives here.
Yeah. And so the two of you, I mean, for you, it's your first job at Hyperganic, I believe, and for you, Lin Han, and for Rahul, I think you've been...
It's a third one.
It's your third one. So I'm going to ask you this question. All so right. How are you how did you get these jobs, and how would you look for a role in AM, if you want to apply for a job?
Yeah, I mean, my present role as a process engineer at the Solution Center, well, I was working with a really niche AM process. So the network, through that, I was contacted because the pool of people at that time was small. But I mean, going forwards, I think a portal like the one that is out here would have been really useful. You really consolidate different sectors to the AM skill set. So yeah, it makes it a lot easier rather than relying on people you may have networked with in the past.
Yeah. Okay, Lin Han? I'm sure now that you're in a startup, there's a lot of opportunities for your company to hire folks. Mm-hmm. What would you, recommend? I mean, is it like word of mouth, or is there any platforms that you guys are looking at?
Okay, so I'll answer this from two perspectives. One, personally, and then the other one will be from maybe the Hyperganics perspective. So personally, I believe in casting my net wide. So I network with a lot of people, connect with people on LinkedIn, and that's actually how I got my job at Hyperganic, because I connected with on LinkedIn with an old friend that is actually helping to set up the Hyperganic Singapore office here. And he reached out to me and he said, hey, we are looking for someone like you. Are you interested? Yeah. But I would say from the Hyperganic perspective, we really look for people through word of mouth. We work with a lot of universities because we're introducing something new, like a new paradigm for people to create and design objects. So definitely we want to go into the universities to nurture them and then lure them onto our platform.
Okay,
yeah.
Great. So we are running very tight on time this morning, or it's afternoon now. So just a quick one. What are the challenges that you are facing? A quick one in AM, and how you have overcome them.
Oh, so I mean, at least in my current role, I started during the pandemic, and I was pretty much the only person based in Singapore. So there was a lot of self-training with remote support, and these are really complex machines. So I think one reason why one good point why I managed to overcome was in AM, especially on technical roles, it really helps if you're willing to be hands-on, like put your hands to the grease and willing to get dirty, right? After all, AM is about materializing digital designs to physical objects. So if you're willing to get hands-on and really dive into the physical aspects of it in technical roles, that really helps a lot, at least at this stage.
Yeah, and for myself, because we're doing something really new, I took around 2 to 3 months to fully grasp the entire gamut of what we do. And talking to people from the technical side, communication, marketing side really helped as well. Yeah. Okay,
very nice. Thanks, guys. Loxley, thank you very much as well. So thank you very much for the three of you. I would love to continue this conversation. Perhaps we'll have to have another episode on this. But that's all the time that we have today, and we've got to get back into a summit proper in a short while. So it was a great opportunity to understand these dynamic global AM trends and learn more about Singapore's digital manufacturing industry. For companies who are looking to hire talent and or if you are looking to be hired, the NAMIC Jobs Portal is your one-stop platform where you can browse both job listings and CVs to meet your career needs. Please visit us at jobs.namic.sg today. And thank you very much to all of you. Good day. Have a good time and see you soon. Welcome back from the AM Career Talks, and I hope aspiring talents found that insightful to advance your career and make it more meaningful in the thriving AM ecosystem. And thank you everyone for joining us today in our final session on social impact with 3D printing. Helming this session, we welcome Michael Patch, Editor-in-Chief of 3D Printing Industry. With almost a decade reporting and researching 3D printing, Michael runs the leading website for news about additive manufacturing. He's a regular keynote speaker and a moderator at technology conferences. And I'm excited to have a chat with him. Hey, Michael, are you ready to join us on board?
Mahendran, how are you doing? Good to see you.
It's always a pleasure, Michael. How are you doing? All good?
Yes, missing being in Singapore for this event this time. Obviously, the conference was fantastic, and not to mention your hospitality. It was marvelous.
Oh, yes, thank you. Thank you for those kind words. Yeah, as ever, we'd always love to have you here. So we're hoping things will open up soon, and next year we'll have this in person, and we'll be able to shake hands again in the flesh.
Yeah. Absolutely. Okay, well, it's a pleasure to be here today with everyone. And this next session, which we're going to be running, as you mentioned, is on the social impact of 3D printing. And I believe we're going to be taking questions from the audience. That's correct, isn't it?
That's right.
And there will be a live panel discussion and Q&A straight after the session. So I suppose I should probably introduce the speakers.
Yes, go right up. Yes.
Excellent. Well, I'm sure everyone else would like to meet the speakers as well. So first up, we will have Ian Cronin, who is speaking on the impact on humanity and can 3D printing change the world we live in and improve our lives. As a community curator for the World Economic Forum's platform for shaping the future of advanced manufacturing and value chains, Ian manages the forum's efforts to build pre-competitive collaborations that advance the implementation of fourth industrial revolution technologies to optimize organizational and regional competitiveness while maximizing positive impact on the United Nations Sustainable Development Goals. Next up, we have invited Ronen Hadar, its Senior Director and Head of Additive Design and Manufacturing in the LEGO Group. Ronen has been working with additive manufacturing technologies for the past 10 years, driving the agenda at the LEGO Group. He holds a PhD in product design and innovation, which brought him first to AM through product and supply chain opportunities. And today he will bring us some insights on the business case of additive manufacturing, a sustainable approach. After hearing from Ronen, we have with us Frank Rosengreen Lorenzen, the CEO of Danish AM Hub, who will share with us his presentation on sustainable production through additive manufacturing. For those who don't know, the Danish AM Hub is the focal point for AM in Denmark, and Frank's role today is focused on additive manufacturing and how to strengthen Danish business competitiveness by promoting the use of additive manufacturing business models that induce growth, innovation, and especially create a sustainable production system and solutions. And if that wasn't enough, finally we have Alvin Tan, who is Head of Technology Catalyst at SG Enable. Alvin brings his strength in technology foresight to the assistive technology domain and seeks to infuse a fresh perspective on the acceptance and use of assistive technology in Singapore. Now, at SG Enable, Alvin is passionate in empowering persons with disabilities by enhancing their capabilities in technology use and helping persons with disabilities to be more engaged with society. In line with his passion, Alvin will share with us more on enabling persons with disabilities through 3D printing. Right, so let's end off this session with a bang. And Ian, let's hear from you.
Good morning, good afternoon, good evening, wherever you're dialing in from today. My name is Ian Cronin. I'm the community curator with the World Economic Forum's Advanced Manufacturing and Value Chains platform. And it's a pleasure to join you, as I mentioned, as we begin this conversation today. And my sincere thanks to the NAMIC Global Additive Manufacturing Summit for having me here today. The topic of this conversation that I'll be bringing to you is on the impact on humanity that 3D printing can bring and how it can change the world we live in and also improve our lives. You know, there's a lot of different ways of looking at additive manufacturing, but I think that as we try to connect the structural elements of how it can actually reshape the world we live in and also improve the lives of those living in it, I think there's a huge opportunity here where we can work together to really drive change and accelerate the impact of this technology moving forward. Very quickly, what I'll do is I'll provide a little bit of background on the context for why I'm talking about this. As I mentioned, I'm with the World Economic Forum and our platform Shaping the Future of Advanced Manufacturing and Value Chains. And as a platform, we look at 6 core priority areas: from shared value creation, resilient value chains, technology adoption, workforce engagement, sustainable production, and leveraging the power of data and data ecosystems to drive innovation. And I think for all of you who are very likely, very closely related to the topic of additive manufacturing, 3D printing, you can see that that could really be seen as a thread that connects all of these. Shared value creation, we're going to spend some time talking about how this can actually improve people's lives. Resilient value chains and how it can reshape the world we live in, and the ideas of distributed manufacturing models. It is a technology itself. How do we actually accelerate the adoption and scale the utilization of the technology? And then, of course, you know, if we look at workforce and data, these are things that are huge enablers to the technology itself. And I saved perhaps one of the key topics here around sustainability for last, and that's really because the technology around additive manufacturing, 3D printing is one where you can see it can have an environmental impact in the traditional way of thinking around sustainability, but also very much a human impact. And so I'll try to touch on all of those different elements and how the technology and additive manufacturing can, again, shape the world we live in, but also improve the lives of those living in it. So very quickly, just getting into some of the core elements I think that I wanted to bring up first is the possibility of the technology to actually reshape how value is created and where value is created in the value chains that manufacturers are using all around the world. I think if we all look back over the last 2 years, there's been a huge number of changes that COVID-19 has delivered, but perhaps one of the starkest was this realization of how fragile our global value chains can be. I've highlighted some of the core statistics that we've done from the World Economic Forum side in the survey we performed last year, but the global pandemic, I think it did create the fragility, but it certainly exposed it. We saw a lot of global megatrends that were shaping the structure of value chains, whether those were these technologies like additive manufacturing themselves, disruptive technologies, geopolitical tensions and trade realignments, climate change. All of these were shaping how value is created and where. But the pandemic has really shown the urgency at which we need to address these challenges. So you can see that shortly after the pandemic took hold in mid to early 2020, already senior executives and supply chain managers were seeing that they needed to think of new ways to create better continuity across their value chains. They needed to overhaul the structure to create better resilience, and needed to focus on risk management as a huge element. And so all of these had huge implications for changing the shape and the structure of the world that we live in when we think about additive manufacturing and how this can actually play a role in that reshaping. I think the big element then when we actually think, well, what does that mean, is getting into the slide I've just changed to here. For decades, supply chain executives have built their supply chains and their value chains on this notion of cost competitiveness. How do I find the lowest cost product with the highest quality? And that has been the key driver, the key underlying theme of how manufacturing executives have built their supply chains. But something like the last year and a half and the pandemic, along with all of these other key trends that I mentioned, have shown leaders that they need to not just think about lowest cost and highest quality, but how do they balance that with this idea of risk competitiveness? How do I make sure that I have distributed manufacturing ecosystem that allow me to adapt if a part of my supply chain can't deliver what I need? And additive manufacturing has the ability and potential to be one of the huge enablers of this new distributed manufacturing model that everybody knows they need to have. They need to think about how to reduce complexity, how to have multiple sources for getting the products and inputs that they need, and having local manufacturing capacity. And there are a lot of ways of trying to get there, but I think that everyone would agree that additive manufacturing is an essential component to that new reshape, that new structure. So again, if we're thinking about how this can change the world that we live in, I think we have to also look at first and foremost, the structure on which our manufacturing value chains have been created. And so that is probably the first thing that jumps out to me when I think of the technology and how it's going to shape the world and improve lives. It's going to change where value is created in our value chains. I think the second part is that we really want to get into here is this idea of improving lives. So and the technology has the potential to do this across people, products, the environment, and it can do it in a number of ways. We've done a large piece of work in collaboration with ETH Zurich and Fraunhofer, and one of the pieces that came out of that research was that you'll see additive manufacturing delivering across key distinction clusters. So we have digital process chains, qualified flexible supply chains, business model innovation, novel AM materials. All of these things are ways that additive manufacturing can help manufacturers create distinct value. But through each of those, there's also this ability to really tangibly and concretely change people's perspectives and change people's lives in a very concrete way. I think a really interesting example that we're seeing this in a very concrete fashion is from a new pilot's being created by the organization 3DP for Me, which is looking at how do you actually leverage the technology in concert with other other advanced manufacturing technologies from scanning and mobile additive manufacturing solutions, new data and design modeling to develop hearing aids for those who've lost their hearing, and for particular for disenfranchised groups of individuals. And I think that you look at a technology like that, and this is something that can really concretely and tangibly change someone's life from one day to the next. Another key example, and again, you'll see the types of examples all across the additive manufacturing space, comes from Johnson & Johnson, where you've seen the actual development of a new material that can be used for bone implants. This is something that can be printed, but it's not just relying on a new method of printing, but actually looking at the material itself. And then I think the third element here is when we really get into the impact that this can have on changing the lives for all of us around the world is on that traditional sustainability element of the environment. There's been a number of studies that have looked at scope 3 emissions, meaning indirect emissions across supply chains. And for a lot of industries and a lot of companies, up to 90% of their total carbon footprint and greenhouse gas emissions footprint comes from those scope 3 emissions, meaning it's from across their supply chains. Well, again, additive manufacturing can play an enormous role in impacting the ability for us to drive down those scope 3 emissions. If we think about a distributed manufacturing model where I am actually creating the part close to where it is being utilized or it's being added to the rest of the manufacturing process, that means I'm not shipping that part across the entire world. Now, obviously additive manufacturing has its own supply chains, but it's far more efficient and economical to ship and transport powder where I can fill up a container 100% of the way rather than ship a part where in any sort of container that's in, there's going to be quite a bit of air that you have just because of the geometry of the parts that you're trying to ship. So if we're just thinking about the efficiency gains that can be created either by not having to ship because of the printing or because of the additive manufacturing supply chain itself and shipping things like powder, you gain an enormous potential for this efficiency that can drive down and improve the sustainability of our value chains and actually have a tangible and concrete impact. Now, achieving all of these requires one thing, and that's scale. And I think that there's probably the largest roadblock for us to actually changing these production systems and improving people's lives is the ability to reach scale being inhibited by the fact that people tend to not want to talk about their success stories. We've been doing a large piece of research for the last 6 months or so through the World Economic Forum, and in having conversations with additive manufacturing OEMs and users, software providers, materials providers, what was caught me again and again was the fact that people are very reticent to talk about their successes. Now, part of me can understand this. The technology, one, has gone through a number of hype cycles. There's this sense of not wanting to feed into another hype cycle. But there's also the competitive advantage that comes from knowing that you have a successful and perhaps scaled industrialized implementation method, and that's an advantage for you in the marketplace. But if we think about the ability for this technology to actually drive true change and for everybody to benefit, and for those utilizing it to have even more benefit, perhaps there's a scaled example in a specific company, but the technology itself is still expensive. The ability for a given company to understand all of the potential applications can be limited in scope simply because of not having all the information of how others are utilizing the technology. So if we can begin to be more open and share our success stories, there's an enormous opportunity for us to actually reach the scale that we need for this to be the transformative technology that we know it can, from a structural enabler of changing the world and the value chains that we all rely on and that we need to continue to function for economic growth, for environmental gains, and then at the same time to translate that into an actual impact for society and for humanity. And so I think by people being more willing, you can see on the screen, there's a number of other challenges around technology, organization, ecosystem. But by talking about our successes and our failures, all of those can begin to have a broader implications for us understanding what's possible through the technology today and what needs to still change and what collaborations might need to exist in order to overcome some of those more systemic challenges that are preventing other gains from happening from the technology itself. So I think that what I would really encourage everyone, if we want to unlock the potential of the technology to change the world structurally and improve the resilience of our value chains and our economies and the overall economic growth potential for everyone, and see the scaled implementation of the technology to actually improve people's lives, whether that's sectors like the health sector, like some of the examples I gave, or for driving down the environmental footprint and impact from a more high level sustainability perspective, then I think what we need to do is talk about how we're utilizing the technology, the successes that we're seeing. So I hope that through events like this, that we're going to hear even more about the success stories from everyone. I look forward to listening to all of it, and I thank you all for your time today. Thank you.
Hello, everybody. My name is Ronen, and I'm from the Lego Group. Today, I'd like to talk to you about the business case for additive manufacturing, and I will put a focus also on sustainability during my speech. In my speech, I'll talk a little bit about Lego, for those of you that don't know the Lego Group. I'll talk about two applications that we are currently exploring together with additive manufacturing, namely additive manufacturing of equipment and additive manufacturing of consumer goods. And then I'll give some perspectives on what should we do going forward in order to make additive manufacturing more feasible. So a little bit about the Lego Group. We are a Danish company, still family owned. We are one of the strongest brands in the world. We're very proud of that. We sell in 120 countries, and probably most of you know us, and probably some of you have children that play with our products. Yeah, what I'd like to also particularly highlight is our planet promise and our sustainability agenda. We have very ambitious targets towards our 2030 goals, where we want to both introduce sustainable packaging and sustainable materials for our bricks by that time. We also want to be completely 100% renewable within our factories, and we have in fact already invested in many wind power or solar power facilities in order to power our factories. So let's talk about the first application, which is the additive manufacturing of equipment. This is probably not revolutionary. I think anybody that is working with additive is exploring this particular application. What you're seeing here on the slide on the left is it's a jig that is used to decorate the face of the Duplo minifigure head that you see on the right as well. On the left, you see the traditional one. On the right, you see the additive manufacturing, and you can also see how we have changed the design to fit the design for additive manufacturing. So why are we interested in additive manufacturing for equipment? The business case here is quite straightforward. Most of the time, we can provide cheaper parts than traditionally manufactured technologies. We can, most of the time, do it faster. We can provide better functionalities. For example, all kinds of snap functions and all kinds of functionalities that are based on material properties. And we actually started implementing a decentral and distributed supply chain. What does that mean? That means that we have implemented small AM factories, essentially, outside of our big production locations. We, in fact, have two locations in Denmark, one in the Czech Republic, one in Mexico. We are currently implementing one in China, and next year we will also implement one in Hungary. That means that we produce on-site, on demand, to service that particular site while we are actually developing all that equipment here centrally in Denmark. And by that, we're eliminating all transportation costs, and more importantly, lead time, which is where which is the pain point that we're trying to address. When people talk about additive manufacturing, we mainly focus on the printing process and the advantages or disadvantages of the printed process. But most of the time, the pain points in additive right now are coming from before and after the printing process. Here, I'd like to particularly highlight the post-processing steps, as you can see here in this example, which is from SLS. Other technologies have different value chains, but they all have a similar pain point in terms of pre and post-processing. And particularly when we talk about sustainability, the waste that is generating in additive manufacturing is quite significant, even though a lot of people talk about additive manufacturing as a sustainable technology. What we are seeing now that we're starting to scale is that actually we're generating quite a lot of waste, even from technologies like SLS. So just before we go into how we calculate the cost of additive manufacturing, just talking a little bit about what we have taken into account. We of course taken into account how many parts we make and what is the build volume and density, the Z height and the refresh rates, development costs and everything else that is taken into account. And also material costs, and even more importantly, waste costs, where costs that are associated with the waste that is generated through the process. When you're considering different AM technologies, not SLS like we are doing in this case, of course, maybe the cost model is changing a little bit. We have in fact also adapted this cost model to other technologies that we are using, and we're seeing similar results in different technologies. So let's look at an example from the AM of equipment. This is a set of jigs that we are manufacturing. We are differentiating between the costs of the first set, where we are taking into account the development costs, compared to the then reordered, or what we call the production sets, which is basically the approved set that just needs to be reproduced in the sites. So the first sets are 445 euros, while the production sets are 265 euros. And that's of course very attractive compared to the traditionally made ones. It's less than a quarter of the price, quite attractive from that perspective. When we look at the cost breakdown, we can see that the first set, the development set, the main cost driver here is of course the development work that is being done by the engineers. What I'd like to highlight though is that the material cost, the second biggest driver here on the development, is 31%. And of course that problem is even worse when we talk about the reproduction of these jigs and fixtures, where the cost driver is about 51% of the total cost. Within that, waste is a major cost driver, and we'll talk about that again when we talk about the consumer goods. So let's get into the consumer goods. When we talk about consumer goods, or AM of consumer goods, we're talking about the possibility of using additive manufacturing for producing Lego bricks. Some people may ask, why does a mass producer like the Lego Group is interested in additive manufacturing? We do in fact have quite a lot of different applications that additive manufacturing would be suitable. For example, when we're looking for new functionality that injection molding cannot provide, when we're looking for business models, especially those that are very low volume, which injection molding is not suitable for, when we're looking for more flexible planning and more resiliency in the supply chain, and of course, again, as we talked about in the equipment part, the digital and distributed manufacturing and supply chain. And lastly, additive manufacturing is most suitable when we talk about the long tail, which is basically the Lego bricks that we manufacture the least of in the portfolio, but are very, very needed in order to produce or provide the uniqueness and the differentiation of the different products. So if we talk about the cost breakdown here, you can see that the main driver actually, and again here we're talking about SLS, for other technologies it would look slightly different, but the message is the same. The main problem is the throughput of the machine. The machine is simply too slow, which means that the main cost driver here is the machine. What I'd like to highlight here though is actually the differentiation we did on this model between the material itself, which is the cost of the raw material coming in, which is still very, very high, significantly, or the magnitude higher than what we would usually pay for materials. But actually highlighting here the 21% for material waste, which is a main cost driver for us in the consumer goods application in particular. And that has been driven both by the refresh rates in this particular SLS technology, by the refresh rates, and other wasteful processes, for example, the post-processing that is being introduced. So we have also developed a comparison model which gives us the possibility to calculate the break-even between injection molding and additive manufacturing. And you can see here that the break-even for a simple mold is around 56,000 parts, and for more complex, more expensive mold, around 93,000 parts. We don't have a lot of Lego parts or Lego bricks that are in these volumes, which makes this particular case not very desirable. We have other examples where the break-even is slightly better and more interesting, but of course, the higher the cost per part is, the less interesting this application is. So let's dream together. What if we could actually increase the productivity of the machine? And one way to do it for SLS is, for example, to externalize or to take out from the printer the heating and the cooling, which just basically waste time in the machine for the machine to be an oven, essentially. What if we could increase the refresh rates? What if we could reduce the material costs? And you can see here that the machine in the cost breakdown, the throughput of the machine or the machine or the equipment is still the main cost driver, again, mainly because of the low productivity of the machine, but the break-even calculation becomes significantly different. The cost per part is 0.4 euros, which actually means a break-even of 174,000 parts for a simple mold and 290,000 for a complex mold. And we do have quite a lot of applications where this is attractive and interesting. Here, I'd like to highlight we're not really looking at additive manufacturing as a competitor to injection molding. We want to take advantage for additive where injection molding is not attractive for us, but of course the cost calculation is still very interesting for us, and we still are asking ourselves, when is it most interesting? So what needs to be done in order to increase the feasibility? We need to, as I mentioned, we need to increase the machine throughput versus the investment, the cost of the equipment. We need to significantly increase the productivity of the machine. We need to lower the machine costs and enable more competition in the market for more suppliers to offer materials for the machines that we have. And we definitely need to start eliminating the waste, which is also causing a lot of the additional waste and therefore higher costs in the process. Thank you very much for your time, and I look forward for a good discussion in the panel. Thank you.
Hello, my name is Frank Lorenzen. I'm the CEO in Danish AM Hub. We are a fund in Denmark established to investigate how we can use additive manufacturing for a more sustainable production system. And we do everything we can to help all producers here in Denmark to harvest the potential of this fantastic technology. First of all, a little bit about the Danish AM Hub. We help define additive manufacturing in Denmark. One of our largest activities is AM Summit, a conference where we gather both international stakeholders, but also our producers here at home. We develop additive manufacturing. We're a partner in World Economic Forum. We're a partner in AMGTA, also several other EU projects and international networks. And also here in NAMIC today, and thank you very much for having me. We're also partnering up with them, and hopefully we'll see you in AdForm Next very soon as well. We deliver AM, so we have 100 Danish producers in projects each year. And the very best of those projects we communicate in cases and have on our website. So do check that out as well. There's a pretty cool bunch of examples on how to use additive manufacturing for sustainable production within that case archive. And also we deploy AM and also have a bit of challenging on additive manufacturing, specifically within the construction sector, where we work with the clever Danish designers and architects on how would we utilize additive manufacturing and also create a more sustainable construction sector. Now, I've been asked today to talk about sustainable production, also the material side. And for me to do that, I'll just tell you a bit about how I see production. And to do that, I have taken a really old case example. This example is 40,000 years old. So that's like a lot of years ago. Just 1,000 years ago, I would have been a Viking. This is 40,000 years ago. It's Löwenmensch, and it's found in what we today know as Germany. It's carved out of ivory from a mammoth. So it's like a really cool artifact that has been found and discovered. Now, what it shows you is something that is not real. So 40,000 years ago, someone has sat down in a cave and carved out this to show people around him or around her that this is something you need to imagine together with me. We are the clan of the Lion Man. You have to follow my lead, and we as a bunch have to create whatever, or have to hunt, or have to gather, or whatever has been the purpose of this statue. Now, if you think about it, today we're much smarter, right? We don't have any symbols like that. But if you think about it, actually there's a lot of lions also in our time. It's really crazy thinking about a company like Peugeot. So the company in itself has, you know, we've as people have gathered imagination power within that and just agreed that we have something called a company. And if, you know, we take a Peugeot car and there is a problem with it, we will sue the company, not the people behind the company. And we also have insurance, which is also something that is in our imagination. So this, people, is what John Lennon was singing about. This is the imagination power of human beings. This is why we've conquered pretty much all of the world. And this is why also we will conquer the universe when we get there. Cool. Now, just to stay on that note, think about triangle trade. So for 300-400 years, we have had triangle trade where we would take stuff here in Denmark, typically weapons, and we would ship that to Africa. Then we would unload. We would take Africans, take them to the States, load typically sugar or others, and unload the slaves, and then take the ship back to Denmark, and that would be triangle trade. 19 million African slaves were shipped that way. It is a dark, dark chapter in our history. And today we think of this as, what were we doing? That is just insane. But if you think about it, no one said, okay, let's do something differently. This here was a typical case of someone has been carving out a lion man and said, now this is what we do today, this is how it has to be. And then people would just follow that lead. Today, we are in a very different situation. When I order some products here in the northwestern part of Europe, typically it would be shipped from Asia. And it would be shipped with really, really heavy machines that are really, really cost efficient. It would be shipped to me, and I can have it within 1 or 2 days. It is a fantastic achievement of human beings that our production system is so efficient and has that high amount of volume, also at a very, very low cost. But the problem is this: it's not good for our planet. Actually, the UN Secretary General could not have been any clearer in his key message. It's a code red. So if you look at the emissions we have each year, we have 51 billion tons of CO2, and it's divided like this according to Bill Gates and Breakthrough Energy. 31% of that is actually manufacturing. Specifically, it's steel, it's cement, and it's plastics. We need a lot of fossil fuels to create the process behind the material cement, steel, and plastics, and then first we start to produce it into products that we then ship. And we need to change that. That is the single most important challenge for production today. It is to changing this system. Cool. So how do we change it and how do we use AM for that? So here in the Danish AM Hub, we look at this example and really like this. It's an example that is 5 years old and it's from Airbus and Autodesk. Look at this partition here. How would you produce it? Typically you would mill it or you would form it in a formative production process, and they didn't do that. They looked at this physarum, which is a mushroom. And it's like a super cool mushroom because if you put it in a maze, it will find its own way out. And it builds these super strong structures around trees. Now you can look at this and figure out, okay, then how, if I put my preconditions within the machine, the algorithm can tell me how would physarum actually grow this partition. And here it is. And it's both stronger and lighter. Now, since it's lighter, it saves the planet 465,000 tons of CO2 each year. That is an immense impact on our planet. This is using tools and skills to create a new production system. Kevin Singer, also in the US, pretty cool example. The car in itself is printed by robots. Typically, a car would have 3,000 parts. This one has 80. Or the steel bridge in Amsterdam, which we also really love. If you look at these 3 examples, the print in itself is only 5 or 6%. It's the method, it's the understanding and the mindset of using the technology for this that is the key factor here. And that is what we're trying to promote in Danish AM Hub. We promote it by looking at specifically 4 areas, either depending on if you want to change your product or if you want to change your value chain. If you want to do so, you could look at these 4 key themes: tools and prototyping, tailor-made products, new business models, and distributed manufacturing. And the cool news is that we actually managed to get Danish producers involved in this. So this is a typical Danish producer. We have thousands of them that will supply something for the German auto industry. And here our CTO, Steffen, has been involved in talking to this company and figuring out exactly how could they use 3D printers within their own production system. Today, this company, even though there are only 100 employees, have their own 3D print center. And they will also take some of the next steps in terms of using AM to a more sustainable production system. This here is Rasmus. He is from the southern part of Jutland, and he is the son of the owner of a Danish company, a really cool company which name is Danitech. Typically, they would create hydraulic blocks like the one here on your right side, which is a pretty normal standard square. And then you would mill in some kind of difficult, the connections you would mill in. But they're not doing that anymore with this specifically, they are printing it. And because they're printing it, they can get a more energy efficient product. And actually, they can save 50% of energy with this product today. So they are actually producing the green products of the future. Are they more expensive? Yes. But are they greener? Yes, and we need to work on the greener side of the production system, and we need to scale that even more. If we look at new business models, our friend Alvin here from Frederiksberg in the northern part of Zealand, he prints glasses. So it's more tailor-made glasses. It's printed in castor bean oil, which is also a pretty cool material you should check out because it has some really good traits in terms of the sustainable side. But here is the notion, right? Here is the killer thing behind his business model. The typical glass industry would have 85% of waste. Alvin in his glass business, Monocool, has 2% of waste. He can even take back the glasses, shred them down, and use that material again for a more circular production method. And my last example is Steen here, also somewhere around, located around where Alvin is. And he creates these more like robotic machines, typically used for clothing industry. And he gives his customers 30 years of guarantee. But now he has a digital file where all his spare parts are in the digital file. So he doesn't need to produce those parts anymore. He can have that in a file, and when the customer then needs it, he will just produce it. So just to sum up, we need to put sustainability first. We shouldn't put cost and volume first anymore. We need to be able to create sustainable products. That is the key challenge. We need to produce when we need it with little or actually no waste. And we need to produce tailor-made products that are long-lasting, products that are meaningful, products that can be repaired and remain in the production system for hundreds of years. And we need to do so in a more circular production model. That, ladies and gentlemen, is what we think in Danish AM Hub. We together should carve out a new lion man and use AM as the leveraging force for sustainable production. Check out our website, amhub.dk, and reach out to me or my colleagues for any more questions or inputs. Thank you very much.
Hi everyone, and welcome to this session on enabling persons with disabilities through 3D printing. My name is Alvin, and I'm from SG Enable, an agency in Singapore that empowers persons with disabilities. Before I begin, just want to express my thanks to NAMIC for inviting me to this session, and I hope this session will be useful for you. Right, let's get going. Let's start with one of the presentation with one of the most iconic characters from the Star Wars movie. Now, Many of you will recognize Luke Skywalker. And I remember back then when I was watching the original trilogy as a kid, there was this scene where Luke Skywalker replaced his hand that was lost in the duel with Darth Vader soon after with a prosthetic arm. Now back then I was thinking, will I see this technology when I grow up? And fast forward decades, while the technology is not exactly there, I would say that with 3D printing, we are a step closer. And on that note, I'd like to share the story about Bella. Bella was born without hands, but through the efforts of Open Bionics, which produced the first FDA-approved 3D prosthetic arm, she's now able to do things that she wasn't able to do before. And let's see what Luke Skywalker has to say about this.
You know, I heard your story on Twitter. Just this morning, my daughter Chelsea was showing me the video of you with your R2-D2 arm. Oh man, that is fantastic. Wow.
I can pick stuff up. Like
that is great. That is so fantastic. So now I heard you're a Star Wars fan, but I have to tell you, I'm a big fan of yours. I'm so proud of you. I'm so happy that you were able to have this happen for you. They call it a hero arm because you really are a hero.
Aww.
This is Mabel. Oh, that's Millie. And can you see that's Chelsea? Say hi, Mabel. There you go. It was great meeting you. And give my best to your whole family. And may the force be with you always.
May the force be with you.
Now, the force is really strong in Bella. I would say that the force is stronger when a community comes together. For 3D printing prosthetic hand, it had an early start in the Enable community. We started as two individuals across 2 different continents who came together over the internet to come up with the first 3D printed hand design, which they put it online for everyone to download. And this enabled anyone with a 3D printer around the world to print a 3D printed prosthetic hand for anyone who needs it. But what's better is that this community actually come together, it innovates, and they come with new designs for the 3D printed prosthetic hand. And that went on to impact even more people. Now in Singapore, a couple of years back, we also tried to use the 3D printed prosthetic hand to help an individual in need. So with this, just wanted to introduce to you Mr. Tan, whom you will see in the bottom right photo here. Now, Mr. Tan came to us with a very simple use case. As a quadruple amputee, what he hopes to do is to be able to pull up his pants by himself. So what happened was a group of innovators came together during this makeathon organized by Tikum Olamika, or TOM for short, took an open source 3D printed prosthetic hand design on the TOM platform and customized it to include the pinching mechanism that you see Mr. Tan using here to pinch the guest of honor. Now, I've been talking about the use of 3D printing for the use to 3D print a prosthetic hand for a person with disability. But I'm sure all of you here will agree with me that 3D printing has a lot more applications. I mean, just do a search on Thingiverse on disability, and you come across designs for, in this case, a pen holder, a key holder, a nail clipper holder, and even a chassis for you to operate the Nintendo Joy-Con with one hand. And not forgetting the mobility aids that helps wheelchair users to get around more easily. And even companies such as IKEA in Israel publish a whole range of 3D printed designs that anyone around the world can print. And this makes the IKEA furniture more accessible for persons with disabilities. And just to share a few other efforts in Singapore to enhance the independence of persons with disabilities. On the left, you see the note identifier, which is designed by a local social enterprise called Edge Empathy. This foldable device basically just allows a person with visual impairments to be able to accurately identify the node that they have in their hands by aligning the nodes to the one end of the nodes identifier and filling for the groove on the other side, which identifies the denomination. And on the top right, you have the condiments holder, which is designed by another social enterprise called Fortitude Culinary. Basically, it prints the name of the condiments in large font, high contrast, and in relief, such that their cooks with low vision are able to identify the correct condiments. And on the bottom right, we see the collaboration between SG Enable and a non-profit organization called Engineering Good. Basically, we customize the coin holder to be able to fit Singapore coins, and we hand this over to a person with intellectual disability, and this greatly eases his anxiety in terms of the coin handling. And talking about collaboration, SG Enable also collaborated with NAMIC, a social service agency called AWA, and an institute of higher learning called Republic Polytechnic, to come up with this customized joystick knob, which for wheelchair users with a very special hand grip condition, they'll be able to use this and fix it onto their existing joysticks on their motorized wheelchair, give them a better grip and control, which allows them to operate the motorized wheelchair better, right? And in talking about other forms of collaboration, for SG Enable, we also administer an innovation fund called the Enabling Life Initiative Grant. And here we have a team that leveraged on this grant to develop the smart auxiliary assistive robotic arm, or the SARA for short. And for this particular arm, they use 3D printing to basically print the majority of the chassis of the robotic arm. Right, so at this point in time, I just want to take a pause here and maybe just give a call out to all of you in the audience here today. If you're keen on any collaboration to develop new solutions for personal disability in Singapore, I encourage you to step off and contact SG Enable for further discussion. So on that note, I just want to briefly cover more about SG Enable. SG Enable, as mentioned earlier on, we are a focal agency that brings together stakeholders and partners to include persons with disabilities as integral members of the society. And we are set up by the Ministry of Social and Family Development back in 2013. Now, one of the ways through which SG Enable supports the persons with disabilities is through the use of technology. And on that note, I would like to share with you more about TechAble. So TechAble is a center for assistive technology which showcases a wide variety of assistive technology. And within this center itself, we also showcase the various 3D printed solutions that I have just mentioned earlier on. And on top of that, together with our partner, another social service agency called SPD, the center provides assistive technology assessment and training, as well as advisory on the use of assistive technology. And through all these efforts, what we hope is that there's more opportunities in terms of work and for learn for persons with disabilities. Now, I won't be playing this video here, but I do hope that in your free time you can go and check out this video to see what TechAble has to offer. Amongst other things, you will see a 3D printed tactile map of the center, which we display right at the entrance of TechAble. And with this, we hope to convey the message that 3D printing can be used to enhance the independence of persons with disabilities and to give them a sense of orientation of the space around them. Or alternatively, you can actually check out the TechAble web app, which highlights all the various assistive technology in TechAble. And you can even take on a virtual tour of the space. So I would just like to end off my presentation with a quote that resonates very well with me. For people without disabilities, technology makes things easier. And for people with disabilities, technology makes things possible. And in my opinion, 3D printing is one such technology that's going to open up many opportunities for persons with disabilities. And I look forward to more developments and more progress in the use of 3D printing that will enable persons with disabilities to be more independent for work, for learn, and for living. And on that note, I welcome you to connect with me, and here are some of my contact details. Thank you very much for your attention, and I hope you enjoy the rest of the proceedings. Thank you.
And welcome back to the studio. Thank you, Ian, Ronen, Frank, and Alvin. It was really a great sharing from you guys. Really enjoyed that. All right, folks. Now we have reached the final session of the summit. Stick around as we engage our speakers in a live panel discussion. I'm sure the panelists have some pretty interesting insights to share with you. All right, let's get this show on the road. Michael, over to you and the panelists.
Thanks, Mahendran. Those questions. So make sure you use the panel in the Q&A, which is on the right of your screen. And if you missed the earlier session, don't worry, the playbacks will all be available and accessible for all viewers after the summit concludes. Now, unfortunately, you may have noticed Ian is not able to join us due to some work engagements. But we've had great presentations from Ronen, Frank, and Alvin, and I'm sure that will allow us to have a marvelous and thought-provoking panel discussion. So, without further ado, let's get into this. Social impact, that's the theme of this discussion. I'd really like the panelists, just to open, to define what does social impact actually mean. And perhaps let's go to Ronen to start off with this, please.
Well, I think the biggest disruption that AM brings is obviously in manufacturing, but the biggest aspect of additive that is a disruptor is the digital manufacturing and the ability to distribute manufacturing all through the globe. So I think up until now, we relied highly on globalization and offshoring. And I think what AM can do is bring jobs back to countries like in Europe or in the United States. Production for local markets is one of the things that I think is most interesting in additive.
And how would you define social impact?
Well, to me, that's something that that really makes a big change in society. That's something that really, that really makes a difference in people's lives and in the products that they use and how they live their life and what kind of offerings they have in the day-to-day.
Okay, thank you. Alvin, so the SG Enable and the general Enabling the Future, the Enable project, that is having a legitimate impact on people's daily lives. How do you sort of view social impact and how it's related to 3D printing?
Yeah, so if I put on the disability hat, I would say that the social impact is more about independence. So I mean, for AM, I think we all recognize that AM will actually greatly bring down the price of production and make solutions more available. So I would say that the progress in AM allows for the development and creation of solutions that could possibly be out of reach for persons with disabilities or anyone else who needs them in the past. So with the consumerization and bringing out the cost, what it means is that the person with disability today will have more options to technology solutions that could assist them to gain independence in their daily lives. So I would say independence will be kind of social impact that I hope can be delivered through AM in that sense. Yeah.
Excellent. I think we'll come back to a bit of that later on. And it's interesting you mentioned bringing down the cost of production now. And I know in Ian's presentation, he was referencing there's a use case of hearing aids, which has been massively disrupted by additive manufacturing. Yes, if you look at the price of hearing aids in 2000, in the US, they were around $2,500 for some high-end components. Now they're around about $4,500. So the cost has actually gone up, and manufacturers are really taking advantage of the custom nature to charge a premium. So it's not always the case of just simply applying additive benefits the end-use consumer. I think we need to be mindful of that sometimes. And anyway, Frank, perhaps you could tell us how the Danish AM hub views social impact and the use of additive within that sphere.
Yeah, thank you very much, Michael. I think first of all, there's a critical area around humans as such, and AM brings a really cool ability, which is tailor-making things. And I just think Alvin's business and his presentation is a really cool example of that. So how to use kind of the tailor-made ability of AM. In Denmark, we have, I think, 4 of the 10 largest producers of hearing aids. And obviously, you know, within hearing aids, if you can create, you know, even more tailor-made abilities within that, you just have a stellar point. You're doing something great to the human being, and you're using the technology to do so. And there's a lot more examples like that, but they're slowly also crawling within something like bicycles, bicycle helmets, and all you know, you could imagine slowly getting even more tailor-made. And I think that that's on the human side, human by human, there's a lot in that. But also, Michael, in my presentation, I talked about this Löwenmensch, right? Which I know is a pretty, it's not something you usually hear in AM conferences. And the reason for that is that I just think as human beings, we need to be aware of the choices you have as a producer in China affects people where on the planet right now. That's what we're talking. So just to, you know, quote one of my friend of mine, the house is on fire, but our things are on fire as well. And we need to figure out then how can we apply this fantastic technology just to help us a bit within this climate disaster. I think right now, if we talk about social impact, I think we should really worry about how do we produce with less cement, how do we produce with less plastic, and how do we produce with less steel? Because those 3 material types, they are fantastic. They have fired up our industrialization, but we need to find business models on how can I create, for instance, a house with less cement. In Denmark, we have a company called Cobot. It's a startup, and they build 3D concrete printers. They just built a house in Malawi in Africa, It's cheap, it's fast, and it's with 70% the carbon footprint compared to traditional housing. So I mean, there are right now things we can do to unleash the fantastic potential of AM. And just my final point on social impact, and I can ramble on within this area forever, but my final point would just be this. It's not something we have to wait for anymore. AM is there. It's only 40 years old, so there's a lot of potential still to harvest it within that technology. And also Ronen's slide on the SLS process clearly shows us that there is a lot of work to do from AM manufacturers still in order to create this technology more sustainably.
Thanks, Frank. There's quite a lot in there. And I mean, it's interesting you mentioned construction. One of my colleagues has just returned from a digital construction trade show this week in London. And it's interesting to see how traditional construction companies view additive, and perspective really seems to be that the whole construction industry would need to change a vast amount to adopt AM, and maybe the world's not ready for that yet. But then in your presentation, you also mentioned some very stark quotes, a dark, dark chapter in our history and a code red for humanity. Yes, here we are on Black Friday, really embarking on a massive stimulation of consumer demand. Is that really what's required right now? So, okay, anyway, but onto the technology really. So Lego put in, I think it was 2019, they were part of a 19 million funding round, putting money into the step technology that Evolve developed, and Evolve obviously came out of Stratasys Shadow project in 2009. Ronen, perhaps you can tell us a bit more about how the Evolve project is going and how you're applying that at Lego.
Unfortunately, no. But I can tell that this is it's definitely one of those. It's just one of the portfolio of technologies that we are interested in and invest in it. I think everybody that knows anything about plastic making knows that Lego's requirements for quality and quantity are some of the top ones in the world. And we realized some years back that, well, if we're not going to create the reality, that it's not just going to happen by itself. Additive manufacturing is not going to come into that level if we're not going to help it come to that level. So investments that we've made in different ways, such as the one that we did with Evolve, is how we are trying to make that reality happen for us, because the benefits of additive are clear to us. It's also very clear to us what we want to do with additive at the end of the road. But the challenges that I highlighted in my presentation are unfortunately not only SLS issues. There are issues across the boards with the quality.
Well, let's talk about SLS, because SLS as a process, it's about 7.78 kilos of CO2 is produced per kilo of PA12. Processing that by traditional SLS, I think, comes out at something like 3.1 kilos of CO2. Then if you use a powder such as Materialize's Blue Sint, which is a recyclable one, you get down to maybe 2.35 kilos of CO2 per material. How does that stack up against injection molding?
So I think you guys have said it just a second ago, AM is only 40 years old. So of course the starting point is looking bad. So if you look at the waste that we generate in injection molding in our factories here is almost zero. We have optimized all our processes in such a way that we are able to close the loops here in the factory and reuse materials. For example, the Lego Group, has also made investments into wind farms and solar farms in order to bring renewable energy back into the grid to compensate for the energy that we are also using in our production. So of course, a one-to-one comparison between additive manufacturing, any technology in additive manufacturing, and the 80% continuous improvement of injection molding is of course not looking very favorable in additive manufacturing for the additive manufacturing side. But it just means that there's a lot of room for improvement and a lot of opportunities for us to gain. Those that know me know that I'm the first to say that I don't buy into AM being a sustainable technology at the moment, right now. But I definitely agree with Frank, for example, when he says that we have the potential on an industrial scale, at least, to make additive manufacturing as a part of the contributing factors to a more sustainable production.
So yeah, Frank, I mean, obviously at the Danish AM Hub, you don't just look at SLS, you see the whole sort of range of additive technologies, which fall under that umbrella of 3D printing. And sometimes people forget that, you've got things like electron beam melting in there. You've got wire arc manufacturing, in addition to the traditional sort of traditional FDM type printing. Do you see any of those technologies standing out as more sustainable than others?
I really wish that I had a clear answer for you, Michael, because I've been really looking deep on that question the last 2 years. And let me tell you, I was just visiting Form Next in Frankfurt, and there are 600 exhibitors there. And I just went to the largest booths and asked them, what is your take on sustainability? How is your technology more sustainable? And no one could, tell me the data, could show me, tangible cases on this is what we've done with this machine, this is what we've done in an injection molding process, this is what we've done in a milling process, and compared to each other, this is the result. I think a lot of the intellectual kind of looking at AM as a sustainable tool right now is moved forward within factories. Also, like the one, like the points Ronen had, that actually he has the numbers on, what technologies in terms of our production and our products are the most sustainable for us. So I wouldn't pinpoint like this technology is cool, this technology, but also just going back to my presentation, people have asked me now for 2.5 years, is AM sustainable? And I just think that essentially that is the wrong question, because no production tool is sustainable. Injection molding is not sustainable. Milling is not sustainable. So let's just pause a second and let's just say AM is not sustainable. Then how do we use it today to create a more sustainable production system? That is what interests me. What are people doing right now, right here, in order to use this fantastic technology to gain a green potential? And I think we have really cool examples in Denmark. I'm so honored to be spearheading this organization, and a company like Lego, Novo Nordisk, or Grundfos, or Danfoss that we have here in Denmark. They use this technology also to gain these advantages already today. And, there's room still, there's a lot of producers out there. There's a lot of AM suppliers out there. Attack this agenda. Show the world how AM can create, design, develop, and produce the green products of the future.
You mentioned business models there, and I think that's...
yeah. Sorry, Michael, we can't. Can you hear?
It's a nice little link into. I can hear you. Yes, I can hear you.
Yeah,
So,
now I can hear you. Now I can hear you. Sorry.
I was saying that Denmark and Singapore, both significant transportation and maritime hubs. And, we've seen via projects such as Deutsche Bahn's Mobility Goes Additive in Europe, or the DNV initiatives in conjunction with Lloyd Register and Keppel Technology, were based in Singapore. Some of these maritime initiatives coming on for creating parts, shortening value chains, but also repair as well, and extending the use of existing components, which instead of creating something new, that's another approach to sustainability there, to make better use of what we already have. Alvin, I wonder if maybe you can talk to this, not necessarily in the maritime industry, if that's not something you're familiar with, but maybe in the area you specialize in as well.
Yeah, in fact, actually, we sort of identify this as one of the potential use case of AM, whereby for the assistive technology devices that the person with disability use, some of them can be quite dated. And when it's dated, chances are you may not be able to find a spare part. But there's a possibility for someone to, say, scan the part and then come up with a 3D design for it, and then we can 3D print it. So I think that contributes to the sustainable discussion that we're having over here. By providing the spare parts that's no longer in the market, you can actually extend the lifetime of the device that you're using, and thereby allowing more benefits at a much lower cost. So I think it sort of contributes both to the sustainability as well as the affordability of solutions that can help the individuals. Yeah.
Okay, Frank. You're probably sort of some of your business partners and people in the network are involved in maritime or involved in these areas. Interesting to hear your thoughts about this, please.
Yeah. Also, I remember Ian's presentation, just looping him back in also into the conversation around distributed manufacturing, or more distributed production system. And sometimes I just take a couple of steps back and just look, why do we even have that conversation? Because it just makes, a lot of sense to be producing really close to the end user. Makes complete sense. I think, no one would say, okay, no, that doesn't make sense. It's because we've kind of built our production system around two things: efficiency and cost, right? And we need to turn that. Around. I think in Denmark being also really strong on maritime and transportation, some of these companies are also moving ahead. I won't tell you specific projects they're doing, but they are also looking at playing a key role within distributed manufacturing, for instance, or how can they use their muscle power in order to unleash that potential, because just it makes a lot of sense, really. Yeah.
I'm interested to come back to that. Maybe this might be an offline conversation, because I know distributed manufacturing is often touted as a wonderful advantage of AM. And conversations I've had with a CEO who I also won't mention questions whether AM legitimately is doing this, or whether production is actually just getting concentrated in other areas. Right. Okay. Ronen, do you have any thoughts about? You mentioned these local production centers for Lego. Realistically, how much production is happening using the local centers compared to the global production, where I imagine scale is a key advantage for Lego?
Yeah, right. I think it really depends on the application, right? So if we're talking about the equipment, as I talked about in my presentation, or the consumer goods, but I can say in general that distributed manufacturing is actually one of the key reasons to do additive in general. So that, in that sense, it doesn't matter what the application is. The maturity of it, however, is different nowadays. So I can say, as I hinted in my presentation, I could say that for equipment, jigs, fixtures, grippers, we actually are already doing distributed manufacturing. Design and development happens here in Denmark, close to our product development and where the engineering is sitting. But production happens on demand, on site, where we actually need these tools. So for example, we have sites in Mexico, we have sites in in China, in the Czech Republic, and that is a reality. We actually do cut all distribution costs and the CO2 emissions that are associated with moving tools and equipment around the globe, which is not a small amount, and especially when that's a critical thing in the old days. Still happens. If you needed something critical in Mexico, then you have like a literal piece of equipment on an airplane on its way to Mexico, because we're not going to halt production because of one piece of equipment. Now we have that flexibility and a little bit more peace of mind to know that if that situation happens, we can send a file printed in Mexico and production is up and running again.
Thank you.
Of course, sorry, Michael. Yeah.
I want to make sure we get through as many questions as possible, so we will be opening up to the audience as well in 5 or 6 minutes. And just a reminder, if you haven't had a chance to ask a question, please do drop those into the Q&A box. We're getting some great ones coming through, so I'm looking forward to posting these to our panel. We've talked a lot about applications, though, here, whether that's in efficient tooling, which is a fantastic application, as you mentioned, Ronen, of additive. But let's talk maybe now about the business models that can make a social impact, not the applications, not those individual components, but the actual business models and how additive might be adapted or might be making a social impact. And Frank, maybe we go to you first, and then we'll work around to Alvin and to Ronen last on this. So maybe you can talk to business models and social impact with additive, please.
Yeah, so I think that one of the cool examples, well, in Denmark is Cobot right now. They've managed to build that company within 3 years. Look out for them. They are really going at it right now. But also here, the 7th of December, we'll bring Danish AM startups together to talk about and just to how can they scale? How would we connect them to more foreign investments also to make that even possible? Because we have just some fantastic examples. We have another company called Bone Homes, and they are looking at a waste stream like plastic, and then turning that into a filament for a large-scale 3D printer that would print a 20 square meter home, typically for students here in Copenhagen and in the rest of the large cities in Denmark. And that is, if I myself should build a kind of an AM startup, I would look at 2 things. I would look at the material side. So I would try and see where can I find, a waste stream would be great. And then somehow enrich that or somehow power that so I can melt that into my print process. And then what tailor-made product would I be able to create? And where would I be able also to loop in the customer within that specific production process? Mm-hmm. I think business models like them, they will just explode the next 5 or 10 years, because we want products that matter, right? We want to be able to have and to say that this product, I am sure that this product has this kind of CO2 emission level, and they've done this and that to reduce that, and what they didn't reduce, they somehow compensated for, and all of that. We want that as customers more and more and more.
So in a way, you get your nutrition information on food. Yes, yeah. Why not the information about how this product's reached you? And the waste stream angle is interesting, and I think a challenge there has obviously been making sure you get that particular material in your batch of waste. So that is a challenge, actually sorting things so you do get the right plastic. But Alvin, perhaps you could talk to business models and additive and social impact, please.
Yeah. So actually, frankly speaking, in my context, the business model and the social impact doesn't really gel that well together. So I think maybe we're having a lot of discussion here about sustainability and the economies of scale, etc. I think I probably represent the long tier, where the usage of additive manufacturing is concerned. I'm looking at a very small use case, but who has a very strong need for such solutions that actually benefit them. So I don't think I really can answer what kind of business models could be applied to make the whole process more sustainable. But I do hope that across the board, as per all technologies, as the progress, as the development happens, the overall cost of production should drop. And when that happens, right, I just hope that the benefits from that lower cost of production could trickle down to the long tier, where this the niche group of users could benefit from this development, right? And yeah, so I think another term probably that is more about universal design. So I think there's room for universal design to be applied to the various products out there. So I mean, hopefully there's more designers who could actually take on this concept in the process of design of the product, and that ultimately could benefit the end users as well through a lower cost of production. So yeah, so I would say hopefully we'll see more development along the way, and that greatly brings down the cost of production. Yeah.
Thank you, Alvin. Ronen, so we've just got time for you to answer this last question before we go to the audience, who are raring with some great questions. So, Ronen, what do you see as the business models that will have a social impact with using additive?
Yeah, I think it very much depends on the decoupling point of companies. So before the business models, I would even ask, where is that company's decoupling point? So for example, those companies that do engineer to order or make to order, and their business models are then based on that kind of decoupling point, are those that are adopting additive manufacturing right now. For example, you talked about the hearing aids. That makes sense, right? Because you almost engineer or make to order these customized parts. Those companies that are maybe more struggling to adopt additive manufacturing are those that assemble to order or make to stock, even the Lego grouping included, right? Where you sort of more make commodities or high volume production. Here, I think it's a little bit more interesting and difficult to find the business models. I'm not sure that business models like customization work on that mass market. I could say that I personally have not heard a big cry in the mass market for things that that consumers want customized when it's not sort of body dependent or something like that. And so I think the business model should be more from a uniqueness, from a new product offering, something that the consumers find attractive, and bring some sort of a new value to the customer. And those that are focusing on cost right now with additive, I think will have a difficult time in these decoupling points, make to stock or make to order.
Thank you very much. Right, so that was our last question from this part of the panel discussion.
So Michael, sorry to interrupt at this point in time. I think, yeah, as you rightfully said, we're just about near the end of the summit, and I'd like to invite everyone to take a look at the questions our audience has left for you. Many exciting ones to be answered, just like what you just said. And so let's quickly dive into the questions, and maybe I'll just pose a couple, and Michael, you can then take over the rest of the questions. Just a quick one. Other than benefiting businesses, what are the top 2 3D printing applications that can impact our lives positively in the next few years? Just a general question to the panel.
Yeah.
Well, I sorry.
Yeah, no, go ahead,
Ron. Yeah, go ahead, Ron.
Well, I think home printing is always an interesting thing that is being discussed, right? Some years ago, when before the AM bubble burst, people talked a lot about, now we're going to manufacture at home, and I think, yeah, the hype around that sort of declined, but there are actually quite a lot of people that work with additive manufacturing or 3D printing at home. making things for their day-to-day. So I think that could be one of the things that is definitely going to, to impact us.
Okay, that's good. Alvin, a question to you. Is that customized wheelchair joystick available in the commercial market? And if so, how does the price point compare to traditional joysticks?
Sorry, I was muted. So currently the customized joystick is available. So if there's any interest, feel free to get in touch with me. I'll get in touch with the producer of the joystick. We can print it according to your needs. So in terms of pricing, I would say that because it's again going back to all the discussion about scale, right? So the scale is definitely much lower. So the cost, I would say, is still be under 100 Sing dollars, which in the context of joystick knob may not be a substantial savings per se, but I would say that at least the design is customized such that it can benefit more users with a very unique hand grip. So going back to the earlier point, I think we talked about customization. I think we should be looking more at the benefit of the customization that provides a solution that's not available beforehand. So while the price point may not be as low as we wish it to be, I think it's a fair price point for a solution that wasn't there before. Yeah.
So the value generated is definitely there to experience. So Michael, I'll just hand it over back to you to continue with the rest of the questions that are being posted by our audience.
Thanks, Mahendran. Yes, so this is a legitimate question that's come in from the audience. Although it probably is one, Ronen, that I would have asked you anyway, because I believe in September 2019, Lego did sort of issue a large number of takedown notices to the maker community regarding copyright or IP infringement. And the question that's come in from the audience is, what is stopping consumers from 3D printing their own Lego blocks? How is Lego addressing this IP infringement?
Nothing is stopping consumers from 3D printing Lego. And the takedown notices were not against individuals and makers and consumers. The takedown notices were against companies.
You did issue one against a fellow on YouTube, I believe.
Yeah.
Who was an adult. Steen Erik Varlag was the designer.
Yeah, so what I was going to say is that the takedown notices were about the use of Lego, the trademark. So Lego does not go after individuals. On the contrary, we think that using 3D printing to extend the play experience is exactly in the spirit of Lego and what we're trying to encourage people doing. But the majority of what we were doing in the takedown notices was to prevent commercial companies from using the Lego Group as a trademark, and for that particular individual also marketing basically a creation that he was selling on that marketplace, also using the Lego Group's name. But everybody's welcome to design and print and play with whatever they want. And on the contrary, if you combine that with playing with Lego bricks, that is the more the merrier.
Okay, and that's interesting. I probably won't go into this more, but if people are interested, if you Google Lego 3D printing, you'll probably find a lot of resources that relate to that conversation. So I hope the person who asked that has had that question answered. Frank, we've got a question for you as well. Between sustainability and cost, how would you advise companies to reconcile these two so that they can take the first step towards AM adoption?
Yeah, that is a really tricky question. That is, if I had a clear answer, I think I would be doing much better. I think, first of all, since we have, such efficient and cost-efficient production systems today, AM will always be, a more expensive choice. Right now, it's just a more expensive choice. And typically, when I talk to small Danish producers, they would be like, yeah, the printer's too expensive, we'll stop. And we're telling them, yeah, you need to be looking at also the other advantages that you get with this print process. Might be, more flexibility in your value chain, a bit more resilience in that. Might be, quicker prototypes that you would be able to do. Might be, having a bit more conversation with your customer in the development product, and also engaging them within the design process. So it's a bit more tricky than just looking at, okay, the printer is expensive, so I'll stop. You have to kind of go into kind of a 360 degree look around the business model from that. And then we see, once they do that, and they see that, and then they start kind of with the first steps toward AM, that they never go back. Then they start, with having their engineers in courses and building, just as the examples I've showed, a 3D print lab. And then from that, they built that experience out. So I would just recognize that, yes, it's more expensive, but what is the value you can gain from that in kind of a 360-year perspective? Specifically, I'm interested in obviously the sustainable side. So how would you be able to use AM today, not in the future, but right now, to save material, for instance? And I think that's maybe, the single most critical part within the AM industry today, is that there is so much potential in saving material with this fantastic technology.
Absolutely.
So let's just find ways for that.
Excellent, thank you. Alvin, you have a fan. We have a question here that says, that was inspiring. What is the most impactful application we can enable with AM for those with disabilities? What is your big ask?
Yeah, I think I'll answer the ask question first. So if you ask me, right, what's my biggest ask, I would say is probably 2 C's. I would like to see more communication and more collaboration. So I think we live in a very good era now. So the internet, basically connects everyone. So the same internet that what Frank mentioned just now, that enables you to get your products across the world in 1 or 2 days, the same platform actually allows for collaboration. And I think in today's day and age as well, right, I think many of us have some sort of access. So we have our knowledge, we have our expertise. What if those everyone can actually take on some social cause and consider putting the expertise into the design and development of some solution that can be delivered through AM, that can benefit the less privileged. Could be person with disabilities, could be seniors, could be needy families, etc. So with that idea of collaboration and communication enabled through the various technology that we have today, I hope to see a search of solutions out there, and even a shorter kind of a lead time to find a solution to a new problem that someone raised up probably in the recent days. So what I really ask for is really more of the communication and collaboration, and to deliver a solution. So I won't say there's a single application per se, but I'd like to see all these technology enablers bringing everyone together and coming up with more solutions. So that would be my ask. Yeah.
Excellent. Okay, so look, we've gone from mycelium-inspired designs to maritime technology to talking about makers. This is why I love additive manufacturing, really, just the real sheer breadth, and the conversations really could have continued for much longer. But unfortunately, that's all we've got time for today. So I'd really like to thank you, Ronen, Frank, and Alvin for joining us. Thank you, Ian, for sending his information across. Just a reminder, this will all be up for review online very shortly. And for now, I'll hand back to Mahendran to wrap up the show, please.
Thank you.
Michael, Ian, Ronen, Frank, and Alvin, thank you for sharing with us how additive manufacturing can transform our lives. These last 2 days spent with our speakers and session chairs have been exciting, deeply thought-provoking, and inspiring. Our deep-felt thanks to each and every one of you for all the cutting-edge content and for helping us to make the NAMIC Global AM Summit 2021 a great success. And of course, the Global AM Summit wouldn't be what it is today without the support from all our viewers. It's my utmost pleasure to have all of you with us. Thank you for taking the time to join us over the past 2 days, and we hope that you have found the summit to be a valuable experience as well. We're not sure what next year may bring, whether next year's event will be physical, virtual, or hybrid. What we do know is NAMIC will continue its efforts in accelerating industrial adoption of additive manufacturing and will continue engaging you. And with that, we'll definitely see you again soon. Till then, do stay in touch with NAMIC's activities by visiting namic.sg and following our social media channels. We will also post news of the summit playback via these platforms. On behalf of the NAMIC team that put together this summit for you, we'd like to thank you and our sponsors. This is Mahendran Reddy signing out. Have a wonderful weekend ahead. Stay safe. See you next time.